Alright, and it is recording. Okay, so today we're gonna do CSP2. We're gonna start off with chapter 10, which is the last chapter, Boolean logic. The reason I want to start off with chapter 10 is because it relates to chapter 1 a lot, and you guys will see in a while why I said we should start from chapter 10. Then we're gonna move on to chapter 9, which is databases. The reason why I want to put that next is because it's completely unrelated to everything else. So the most correlation in that is just data type. So it'll give us a basic understanding for chapter 7, which is what we're going to do next, leaving chapter 8 for last. So let's just, okay. Now, when we talk about, when we talk about computers, okay, so I think, yeah, my Wi-Fi killed itself. Okay, so I was saying that we're gonna do chapter 10, we're gonna do chapter 9, and then we're gonna move on to chapter 7. So when we talk about computers, obviously computers don't read, write, and do all of that stuff on their own. So we know that computers, they work on arithmetic calculations and multiplication, division, all of that stuff. So that's where Boolean logic comes into play. Boolean logic, it utilizes different gates, okay, like the AND gate, the OR gate, the NOT gate, all of these to manipulate bits, right? So we're just gonna cover a bit of each one of them, and we're going to just have an overview of them. We're gonna see how logic circuits work, and we're gonna start off with chapter 10. Let me just pull out some notes, some screenshots, sorry, and we're gonna start. Where the hell is it? Okay. Okay, I'll just pull out C notes, I guess. Okay. CAIE, O level, IGCSE. Where is it? Computer science, practical, Boolean logic. Okay, so when we talk about Boolean logic, like I said, it's a way to manipulate bits. Okay, so it's a way, you know, that everything it depends on a bunch of zeros and ones. So what Boolean logic is, it's basically just a way to manipulate these zeros and ones. So let me just create a new note, and let's name this chapter 10, Boolean logic. So when we talk about Boolean logic, there's 6 different gates that you need to know. The first gate is called the NOT gate, and we're going to go over each one of these. The second gate is called the OR gate. The third gate is called the AND gate. These are the 3 basic gates that you should know what they do. So the NOT gate is basically used to flip switches. So if you have a light turned on in your room and you turn it off, you can theoretically say that you made the light go through a NOT gate, because you just turned a 0 or a 1 into a 0, right? So you just turned an on signal into an off signal. That's what the NOT gate does. It basically converts an on signal to an off signal, or an off signal to an on signal, right? That's what the duty of a NOT gate is. Now, one thing that we're going to notice a lot is called truth tables. Now, I told you we mainly use these to manipulate bits, right? In A levels, in AS level, if any one of you takes computer science, you'll learn something called bit manipulation. So there's something that we call, let me just zoom this in for you guys as well. It's called truth tables. What truth tables are is they're basically a method to represent all of these different types of bit manipulations, right? So we usually have inputs and then we have outputs. So if we look at how a NOT gate looks like, right? So let me just fetch an image of a NOT gate. So let me just copy this and paste it over here. So you can see that in a NOT gate, you can see that there's an input on the left side, and then that goes through, and then there's an output on the right side. So for a NOT gate, there's only one input, which I labeled as A, and then there's only one output, which I labeled at X. Now there's only two possibilities of A. The first possibility is that A is equal to 0, and the second possibility is that A is equal to 1, right? So I told you guys, NOT gate, pretty simple, just used to flip the bit. So if it's a 0, it becomes a 1, and if it's a 1, it becomes a 0. So if you plug in a 0 into a NOT gate, that will become an output of 1, or if you plug in a 1 into a NOT gate, that will give you an output of 0. That's the first thing. That's the first gate. You should know what the NOT gate is. It's pretty simple. Then you have the OR gate. Now, the OR gate is okay. Let me copy an image of the OR gate as well. So the OR gate, it looks something like this. So it's kind of like has this curve at the start, and unlike a NOT gate, it takes in two inputs. Now I'm gonna teach you guys a really easy way to measure all of these inputs. So let me just remove this table right over here, and let me just tell you guys how these inputs look like. So in the exam, you'll be given something like A, B, A, B, and X, right? And maybe you'll be given some working space in between. So that's what a truth table looks like. So in the case of two inputs, you have the possibility of 0, 0, 1, 1, 0, 1, 0, 1. So you don't really need to memorize this notation, right? It's not necessary. So in the case of an OR gate, you have a 0, 0, a 0, 1, a 1, 0, and a 1, 1, right? So in an OR gate, you can think of an OR gate as a plus symbol, all right? We also signify an OR gate using a plus, but we'll get to that in a while. So an OR gate, you can think of it as a plus. So what's 0 plus 0? That's just equal to 0. What's 0 plus 1? That's just equal to 1. What's 1 plus 0? That's equal to 1. What's 1 plus 1? That's usually equal to 2, but we're just gonna write it as 1, okay? That's what we're gonna do in an OR gate. We're just gonna add the values, okay? Don't accidentally write 2 using this logic. You can also remember this as, if there's a 1, then the whole statement's gonna be true, okay? So an OR gate can just be used to merge bits, okay? So that's an OR gate. The next thing that you have is an AND gate. Now an AND gate uses a multiplication principle, okay? The AND gate uses a multiplication principle. It looks almost the same as an OR gate, except it's more straightened at the left side, right? Just like that. So it's more straightened at the left side. Now in the case of an AND gate, you have the same things, A, B, X. You have 0, 0. You have 0, 1. You have 1, 0, and then you have a 1, 1. Now in the case of an AND gate, you can think of it as multiplying. So 0 times 0, that's just going to be 0. 0 times 1, that's going to be 0. 1 times 0, that's going to be 0. And 1 times 1, that's just going to be 1. So you can think of it as like kind of like multiplying, right? So you're multiplying the two values, okay? And that's also how you represent this in Boolean logic. We'll get to that in a while. But basically, you can think of an AND gate as if you're multiplying it, okay? So an OR gate, you can think of it as plussing, adding something, and an AND gate, you can think of it as multiplying something, and a NOT gate, you'll think of it as switching bits. Then you have the 3 derived gates. Now the derived gates, they include the NOR gate, the NAND gate, and the XOR gate. So if you pay close attention, you'll notice that these names are very similar to their normal counterparts. So in the case of a NOR gate, all you have is the same thing as an OR gate, except you have this little dot after the gate. This is used to signify a NOR gate, right? In the case of a normal OR gate, it's just that, and in the case of a NOR gate, you just have a dot at the end. Now the NOR gate, or any gate that like starts with an N, which also includes the NAND gate, is just going to be that normal gate, and you just invert the values at the start. So for instance, let me just copy this table. Okay, let me just copy this table, and let me just paste it over here, right? So you have ABX. Now in a normal OR gate, you'd have 0 plus 0, let me just remove these values. In a normal OR gate, you'd have 0 plus 0, and this would be equal to 0. In a NOR gate, you would do the exact same thing, except at the end you will inverse the bit. You will reverse the bit. So a 0 becomes a 1 and a 1 becomes 0. So 0 plus 0 in an OR gate would be 0, but it'll become a 1 in a NOR gate. The N basically stands for not OR. Okay, so you can think of it like that as well. So 0, 1 in an OR gate would be 1, so we take that as a 0. 1 plus 0 would be a 1. We take that as a 0. 1 plus 1 would be a 1. We take that as 0. That's basically a NOR gate. Now, next you have a NAND gate. Now, like the NOR gate, all it is the normal AND gate, except there's a dot at the end. So this looks something like this. And we're just going to copy the same truth table again. So let me just copy this. So, like I said, any of these not AND or not OR gates, they're the same truth table, except in the end you just invert the values. So 0 times 0 would be 0, but in the case of a NAND gate it will be 1. 0 times 1 would be 0, we'll just make it a 1, and so forth. That's going to be NOR and NAND. Then you have the XOR gate. Now, the XOR gate is one of the most confusing ones, but I'll just give you a simple statement to remember it. The same statement I used to remember it to this day. If same, then false. It ends up going on your tongue. It's a very catchy phrase. So if same then false, what this means is that for a truth table, like okay, let me just say, okay, so for a truth table with you have A, B, and X, and you have the values. So 0, 0, 0, 1, 1, 0, 1, 1. So in the case of an XOR gate, if same then false, that means that if the value of A and B are the same, then we're going to write the total value as 0. So then you have this as 0, then you have this as 1, this is 1, and this is 0. So if same then false. That's the easiest way to remember the XOR gate. It's a catchy line, you'll catch on to it. Now, besides these, you have logic statements. Now, if there's two things that you need to know. The first thing is called the Boolean logic. The Boolean logic, it looks something like alright. So Boolean logic would look something like this. Okay, so let me just pull out a hold on, let me just pull out a, where is it? Okay, I think it's this. No, it's not that. I think it's this. Okay, I'll just use this. Okay, so a normal Boolean logic, it would look something like okay, let me just zoom out. So if you have, for instance, a NOT gate and you have the value of A, not A would just be a dash on the top. So a dash is used to signify not. Alright. Now in the case of an OR gate, like I said, it follows a plus principle, so you can write A or B as A plus B. Alright. In the case of an AND gate, you can write A dot B. Right, so dot is used to signify the multiplying principle. Alright, now for the NAND and NOR of these gates, all you have to do is just add dashes, right? So you can just add a dash on A plus B and A dot B to signify the NOR or NAND gates. Now that's basic Boolean logic, and then you of course have the XOR gate. Alright, so these are the basic Boolean logics for these. Right, so besides this, you have Boolean logic statements. So what they are is okay, so there's going to be three kinds of questions that can come. The first type is the ones that we derive from a Boolean circuit. So for instance, you can combine multiple gates. Okay, so like for instance, if you have values like A, B, and C, you can combine these together in the form of multiple gates, like for instance here, right? And you can like bring out the values from the other side, right? So you can combine values like this. The first method is to use it using logical circuits. So in this case, how we would write something like this is to basically you divide the problem up into some parts. So firstly, you would notice that there's a junction right over here. So what I'll write this as is A and B, right? So it's pretty simple so far. It's going to be A and B. Now I'm going to put these in parentheses to signify that it's a junction, okay? And then you have the second gate, so you can just imagine bits flowing through these wires, and then this whole thing goes into an OR gate, which is going to be OR C. So that's basically how logic circuits work, okay? That's how logic circuits work. Now that's the first derivation that you will have. The second derivation is from a truth table. So this is a bit more complicated. Okay, this is a bit more complicated. Now, like I said, you can represent logical statements. You can represent logical statements using logic circuits. But how would you derive a logical statement from a from a truth table? Let's assume that you have a table like, for instance, you have a table. Let me just bring out a random ass table. Let me bring out a past paper. Actually, we can just copy paste this from past papers. But okay, just a sec. Alright, so let's assume that you have a truth table that looks a bit like this. Okay, so you have the A, right? You have the A, you have the B, you have the C, and you have the X. And let's just say that the values, they look something like this. So let me just write these down for you. 0, 0, 1, 1. So this is a bit more complicated. There were a lot of people from my session who did not know how to do this, and this did come in our exam for like the variant 2, so you guys should know how to do this kind of a question. So then let's just assume that it's going to be 0, 0, 0, 0, 1, 0, 1, 1. Or actually, let's just turn this into a 1, this into a 0, and then this into a 1. So the question is that you need to derive a logical expression from this logical truth table. Okay, so in order to do that, the first step is to isolate the ones. What does that mean? So for instance, what you would do is you would mark a row which has the x value, the output value of 1. Okay, so you would highlight this row, and you would highlight this row, you would highlight this row, and basically you just highlight all these rows. Now you have 4 rows which have the output of 1. Okay, that's the first step. Now the next thing that you're going to do is you're going to basically make all of the ones, force all of the ones. How does that work? So you're just going to take each statement and you're just going to add an A and B and C. Okay, that's what you're going to do. And then you're going to add an OR in between them. Okay, so let me just explain this in a bit. Okay, let me just write this down and I'll go over it and how this works. Okay, and B and C. Okay, so first of all, you write A and B and C for however many rows there are in which the x value is 1. Now the next thing that you would do is you would take either A, B, or C. C if it's a 0, and if it is a 0, then you just write not before it. So like for instance, in this first row, which is this row right over here, we can see that A is a 0. So what I'm going to rewrite this is as not A and B and C. Okay, not A and B and C. Then you have the second row, which is this one right over here. So I can see that B right over here is a 0. So I'll rewrite this as A and not B and C. Then you have the fourth row right over here. So I can see that C is a 0. So I'll rewrite this as A and B and not C. Then you have the last row in which all of them are 1, so we don't need to touch that. And this will be your final truth logical expression. And remember to lie equal to x. Okay, remember to lie equal to x. This is how to derive a logical expression from a truth table. You should know how to do this. The reason that this works is in the end you're essentially just taking all of these values and you're forcing them to become 1s. Okay, you're just forcing them to become 1s and then you're just adding them up. Okay, I could go behind the sides, but then we'd be stuck here all day. Alright, so that's the second way of deriving logical expressions. The first one was through through logic circuits. The second one was through a truth table. Now, the third kind of a logic circuit is one that uses a problem. So, for instance, you have something like this. Okay, so let me just increase this in width. Can I do that? Okay, I can. Okay, so in this scenario, what you gotta do is you gotta listen. You gotta look at the statement at the bottom. Okay, so it's basic English. So either turbine speed is less than or equal to 1000 RPM and bearing temperature is greater than 80 degrees centigrade. So what you're gonna do is you're gonna match up the statement to the table. So for instance, turbine speed is less than or equal to 1000 RPM. That is going to be S and 0. So what we're going to do is we're going to write this as not S, which means that we're basically signifying it as a 0. And they said bearing temperature is greater than 80 degrees centigrade. So we're going to write an and, right, because they use the word and we're going to look, bearing temperature is greater than 80. That's just going to be a T. Alright, now the next word they used was an or. Alright, the next word they used was an or. So we're just going to write an or in the center, and then we're going to work on the next statement. So turbine speed is greater than 1000 RPM. That's going to be right over here. So again, turbine speed S greater than 1000 RPM. It's already 1, so we just need to write it as S. And then again, they use the keyword and, so we're going to write and then they use wind velocity is greater than 120 kilometers per hour, which we can see is already a 1, so we're just going to write it as a W. Okay, now the next thing, keyword is also an or. So now let's go on to the final statement, which is going to be bearing temperature is less than or equal to 80 degrees centigrade. So bearing temperature less than or equal to 80 degrees centigrade, that's going to be not T. So we're going to write this as not T. And then again, the keyword they use is an and then wind velocity is greater than 120 kilometers per hour, which is already going to be a W. And again, don't forget, you need to write the output variable that is going to be given in the question. So for instance, in this question they mentioned that it is the output X. Okay, so that is how you use you derive it from the from the problem styled question. So this is how you derive logical truth tables. We're gonna go into techniques on how to solve these things when we do the past papers, but yes, let's just write it over here as well. So you use X is equal to A plus B, X is equal to A dot B. But yes, that basically sums up all of chapter 10. It's just that. It's that easy. So do you guys have any questions, anything whatsoever? Let's just go over one last thing, and that is how to actually work with truth table, how to actually work with logical circuits. So for instance, if you have a logical circuit such as A, B, and C, and you have a bunch of logic gates passing through it, right, like this, right, so the easiest technique to use for this, I'll tell you guys the easiest technique to use for this as well. Okay, let me just bring this over here. So for instance, this is a logic circuit, right? Now the easiest technique to use for this is to make additional letters. So after ABC, you can say that this is gonna be D, this is gonna be E, this is gonna be F, and this is gonna be X. So you can use these different letters as placeholders, and you can calculate the value of each one of the letters through that way. And we'll get to this when we do past papers, but yeah, that basically sums up all of it. You should obviously go in junction, so you would complete this part first, and then you move on to this part, and then you do this part, and then you would do the whole entire circuit. That is basically logic gates. Any question from chapter 8 whatsoever? Sorry, chapter 10. Apologies. Any question from chapter 10 whatsoever? Okay, let's just work with some definitions. So the only definition you should know is what a truth table is, right? So you should know that a truth table, let me just write it down as well. So you should know that the definition of a truth table is that it's a method of checking the output from a logic circuit or a logical expression, right? So that's the technical definition for it. Now that basically sums up chapter 10. Do you know where to find some practice how to do Boolean expressions? Just do past papers. Just do past papers, right? Can you show the types questions where they give you examples? We just covered them. The strategy to do these kinds of questions, like the one here, this is like one of them, right? So the strategy to do these kinds of questions is to just look at the English. Okay, so for instance, right over here, they wrote either turbine speed is less than equal to 1000 rpm. So you basically take this keyword and you match it with the table. So where is turbine speed is less than 1000 rpm? That is right over here. So the binary value is 0. So you basically want to turn this 0 into a 1. How would you turn a 0 into a 1? You would add a not before it, right? Now, what is the parameter? What is the letter of this entire thing? That's S. So we wrote not S. Alright, then they said and. So we're going to write and in the between, okay? So the best way to go about these is to use English, right? So and then the next one was bearing temperature is greater than 80 degrees centigrade. So we're just going to use T, so not S and T. Right, now the next keyword they used was an or, so we're just going to write or, okay, and then we're going to do the second condition, which was turbine speed is greater than 1000 rpm. Again, match this in the table, you'll see that it is basically equal to S. So S and W, right? So again, they use the word and. Wind velocity is greater than 120, so right over here you can see that it's W and it's already 1, so we don't need to touch that. And then lastly, the last statement was also an or, so we just wrote an or. And then you write bearing temperature is less than equal to 80 degrees. So bearing temperature is less than equal to 80 degrees right over there. So since it's 0, we need to turn that 0 into a 1. So we're just going to do not T and, again they use the keyword and, wind velocity is greater than 120. So we're just going to do not T and W, and we're going to make this whole expression equal to X. Alright, that's how you do the table kind of questions. Alright, so any other questions besides this, or should we move on to chapter 9, which is databases? Okay, let's move on to chapter 9. Chapter 10 is really simple. All you need to do is to do practice. So chapter 9, databases. So when we talk about databases, okay, so we know that each data can be stored in a collection. Okay, we call this collection a database, or the technical definition of a database is that it's a well organized compilation of data. So a database is basically a well organized compilation of data. So you basically you can say that it's used to retrieve information. Okay, so you can say that it's used to retrieve information. So it's basically you basically have a big ass table and it has a bunch of values in it, and you just use a database to store these values and to get these values, right? So you should know why we need a database. So obviously when you have like a lot of people, for instance, or you have a lot of things to store, that's when you use a database. Okay, you have a lot of objects to store and you want to be able to fetch them instantaneously, you'd use a database to store all of them, right? So there's a few reasons, right, that you should know for your exams. So reasons to use a database. So the first one, like I said, is that you get to store information about people, events, or objects, etc. Right? So for instance, you can say everybody in this VC. If I wanted to make a database of everybody in this VC, I would get your all's username, I would get your all's name and your all's PFPs maybe, and I'd store that in a database, right? So you can just use a database to store information like that. The second reason is that modifications need to be made once. what does that mean? So let's just say one of you all changes their display name. That means that all I need to do is to update that in the database once. Okay, so this leads to data consistency, right? So that just means that data is consistent throughout. It doesn't get jumbled up. Okay, and so on and so forth. Someone tagged me when he's on pseudocode. We're not gonna do pseudocode today. We're gonna do pseudocode tomorrow. Okay, we're gonna do pseudocode tomorrow. Then you have okay, so you have little no data duplication. No data duplication. What this means is that if you have one user inside of a database, then it's just going to be that one user. You can't duplicate data. You can't have multiple data or multiple users with the same username. We're going to talk about this in a while as well. So you should know what tables are. Okay, so you should know that in a database, data is stored in tables. So what that looks like is, for instance, let me just insert a table right over here. So let's just say that I have a database of everybody in this call. So I have their username, their display name, how long they've survived, how long duration, right? Duration of them being in the VC. So for instance, I can say that myself, ateebsohail, the display name ateebsohail, and I've been in this VC for 30 minutes or 40 minutes, something, right? I can say another user. I can add another user, like so there's Halo in this thing. Okay, so I can write Halo, right? So Halo dot genation, right? And I can say that his display name is Halo and he's been here for 30 minutes, and this goes on and on and on. Okay, so like there's other people. I can write for instance Avana, so I can write Ayat royalty wait, and she's been in this VC for 20 minutes, and so on and so forth. So it's basically a collection of data, right? So I can just go on and on and on and write about every single one of you lads, and that's basically what a database is. And now this whole thing, it's called a table. Okay, so data is stored in tables. Now each one of these things, each one of these rows is called a record. Okay, so each row is called a record. So this row right over here, comprising of my name, display name, and duration, this is a record. All right, this is also a record, and so forth. Right. So then you need to know what fields are. The username, it's a field. The display name, it's a field. Duration is a field. Let's just say I wanted to add age as well. So I'd go age, and then this is also a new field. So I'd go like something like 45 years old, 12 years old, I don't know, like 18 years old. So it's basically fields. Okay, so these are fields. Okay, they're fields. So you should try out Microsoft Access. All right, that's a software we use for database management, though I think it's a bit too late to do that, but that's basically in our syllabus. We just use Microsoft Access. We refer to Microsoft Access a lot. Now we have validation. Okay, so the thing that we use to enter this data, it's called a database management software, or DBMS. You'll go into this more in AS level, and in the DBMS you have validation, right? Which basically means okay, so it basically means that during construction, data validation checks are set by the developer. So for instance, I have a display name, or actually let's just go with username. So I can add a check. I know that in usernames it can't be something like it can't be something that has a capital letter. I just realized that this is very wrong, but I can like have a validation check that says that it can't be a capital letter, it can't have spaces. So these are all validation checks, right? We're going to learn about this a bit more in chapter 7 as well, but these are all validation checks. Now each one of these values right over here, they can also be categorized down into data types. So these data types in databases, are text or alphanumeric. So text slash alphanumeric. What this is something like ateebsohail, right? So it has text, or it can also have numbers. So it's a basic string. Okay. The next thing is a character, right? So a character, something like a. Okay. The next one is boolean, so something like true or false, right? So let's just add a boolean here as well. Is alive, right? So false, true, true. So that's boolean. Then you also have real, right? Real, which is basically a number that goes into decimal, so like 10.04. Let's add that here as well. Let's call it level, right? So let's just give myself 99.34, 20.230, 20.33, and 2.22. So that's what we call a real. Okay. Now then you have a date slash time. Okay, date slash time. So these are the data types that you have in databases. Now the next thing that you should know is what a primary key is. Okay, so a primary key is a field that's used to uniquely identify a record. It's unique and cannot be duplicated by any other record. So in the case of Discord, if you try to change your username to something like mine, right? So if you try to change your username to ateebsohail, it'll give you an error that a user like this exists. A user with that username already exists, right? So that's basically what a primary key is. So in our case, primary key would be something like the username. So it's unique. Okay, it can be used to uniquely identify a record, right? So for instance, if I wanted to fetch this entire record, I could say that I can fetch this entire record by just looking for ateebsohail, right? So I'll just say that the username is the primary key. The username cannot, the primary key cannot be duplicated. Okay, there can't be another ateebsohail, and there can't be another halo.generation, or there can't be another royalty with, and all of this. Yeah, so there can't be duplicates of the primary key. So the marking scheme definition, you'd write a field that's used to uniquely identify a record, and yeah, that's basically a primary key. So yeah, that's basically what primary key is. The next thing is SQL. So any questions so far about all of this? Any questions so far? Before we move on to SQL. Bro, is this the whole syllabus? We're going to try to do the whole syllabus today and tomorrow. When is trace tables? That's going to be chapter 7, so after this chapter. Alright, so before we move on to SQL, let's add a bit more data to our table. So we're just going to use this table that I made on top, and let's just add a bit more fields to it. So let's just add something like city, and we can say like Peshawar, Larachi. We can say something like planet, Earth, Mars. What the hell, Mars. Okay, I can add more usernames. So let me just fetch random people's usernames. Okay. Okie flakes. Okay, Okie flakes. Verb. And I'll say 20 minutes as well. So age, let's just write that as 18 as well. Is alive, false. Minus, or actually let's just change this to 100.2. City, let's write this as Karachi, and planet, let's slice this as Jupiter. So let's just add one more user so that we have like a bit of consistency when we're practicing SQL. So let's just add anybody from here. So okay, let's just go with you. CUSFYT. let's just say you've been in this VC for 0, 0, right? Let's just say that your age is like 105. Let's say you're true, your level is 100.2 as well, and your city is Islamabad, your planet is also Earth. Okay, so we have this small table, and let's work a bit with SQL. So what SQL is, we call it SQL, you call it SQL. Okay, you can also pronounce it as SQL. It basically stands for Structured Query Language. So the name obviously suggests that it uses something that we call something that we call to search queries. Okay, so we learn how to fetch data from a table using queries. So in the IGCSE syllabus, we have a few. Let me just pull out the IGCSE syllabus on my right as well. Hold on a sec. So in the IGCSE syllabus, we have a few SQL statements, okay, SQL queries. So these are the select, right? Select, the from, where, order by. I believe. Let me just confirm. I'm unsure because the syllabus changed in regards to these a bit. So let me just confirm. Okay. Okay. Select, from, where, order by, sum and count. Sum and count. Now the question is going to ask you to write an SQL query. Okay. So the basic SQL query, the thing that's going to be universal for all of them, is the two statements which are, let me just write universal for all queries. The two statements which are select and the from statement. So let's go over this. Let's say that this table is called table name, and let's call this CS sesh. Okay, let's just call this. Okay, so the select thing is used to select fields. Okay, so I'll also write this over here, fields, right? The from is used to select the table name. Okay, so for instance, let's just say that I want to select the username field. Okay, I want to fetch the username field. So I would do something like select username, and the table name is CS sesh, right? So I'll do CS sesh from CS sesh. So these are just universal queries. Okay, now if I were to run this query right now, what it'll do is it'll just fetch me this entire table right over here, just the username. Let's say that I also want to fetch the city. What I would do is I would do select username, comma city. Now what this will do is that it'll show me all the usernames along with their respective cities. I can also say something like select star or an asterisk, right? So what this does is that it'll fetch me all of the fields. Okay, it'll fetch me all of the fields. Okay, now that's basically what select and from are. There's always going to be a select and from in each one of these SQL queries. Okay, now the next thing is the where thing, where condition. Now the where thing is mostly used to specify a condition. Let's say that I want to fetch all of the users who live in Larachi, so I would do something like where city is equal to Larachi. Okay, now let's say that I want to fetch all the fields, select star, right? So select star from CSS where the city is equal to Larachi. What this will do is it'll fetch me all the users and all of their fields, which is just going to be halo.generation and IELTS, right? So this is going to be these two people, and it'll basically fetch me this purple thing that I've highlighted. Okay, it'll just fetch me this purple thing that I've highlighted. So that's basically what it's going to do. Okay, that's what a condition is. Now let's just say that I want to fetch a specific user, for instance. Let's just say that I want to fetch royalty wit. So I could do something like where username is equal to royalty wit, right? So that's another way to fetch one of these. So then there's other conditions, like for instance, let's say I want to fetch all the users where they're alive, right? So I can do something like where is alive is equal to true. Okay, that's for Boolean. Okay, then you have the collective thingies. Okay, so like for instance, you have something like you want to fetch all the users who are between the ages of 10 to 20. So I would do something like age is greater than or equal to 10 and age is less than or equal to 20. So that's another way to do this, right? So that's another way to specify a condition. Let me just okay. All right, so that's another way to specify these conditions. So then what you have is the next statement, which is order by. Okay, order by. Okay, let me just make this a less than sign. Let me just remove this. Okay, let's just say I want to fetch all the users whose age is greater than like 20. Okay, so the next thing is the order by statement. Now order by statement is basically used to what do you say, is used to um, order the sequence in which the queries come. So like for instance, if I were to do order by ascending and I were to select all of the fields and all of the records, and I selected like for instance a username field, what it'll do is it'll first show me ateebsohail because it starts in A, and then it'll show me CUSFYT because it starts with C and that selects the alphabet. So that's basically what order by ascending means. It means going from the smallest to the largest. If I were to do this with a numerical field, it would go something like it'll show the 12-year-old first, then the 18-year-old, then the 18-year-old, then the 45-year-old, and then the 105-year-old. Same goes for the float values, and same goes for any other string value or a date/time value. It basically does it that way. Okay, so there's order by ascending or there's order by descending. Okay, so there's ascending/descending. Okay, so there's two types of order bys. Now the next thing is mainly used with the select field. Okay, the next thing is mainly used with the select field. So let's say that I want to fetch the sum of all of the levels of everybody. So I would do select sum level from CSS, and I would remove both of these fields, right? Because I'm just selecting the sum. So what this will do is it'll take all of these levels and it'll add them together. Okay, now let's say I want to fetch the sum of all of the levels which are greater than, let's just say 30, right? So I would do something like select some level where level is greater than 30. Okay, what this will do is it'll fetch this one, and this one, right? It'll fetch this one and this one, and it'll just add these values together and it'll return it. Okay, so sum field. Okay, so it'll just be a sum of field. It'll return sum of field. Okay, then what do you say? Then lastly you have the count again, which uses the field thing. So let's just say that I wanted to count the number of fields or the number of records which have the is alive flag as true. So I would do select count is alive, or let's just say select count username, or you can actually just do is alive, it's your own choice. So from CSS where is alive is equal to true. So what this will do is it'll find all of the values where is alive is equal to true. So there's one right over here, there's one right over here, and there's one right over here. It'll count them, so in this case there's 3, and it'll just return the value of 3. Okay, that's how SQL works. And basically that's it for SQL. The next thing you need to know is in these conditions there's a few operators that we use. So operators, let's just talk about these operators and then we'll close chapter 9 as well. So okay, let me just okay, so these operators, they look something like okay, so these operators, there's the equal to operator, there's the greater, I'll put these in a numbered list as well. There's the equal to operator, there's the greater than, there's the less than, there's the greater or equal than, there's the less than equal than, then there's the not equal to, right? There's not equal to, then there's between, like I don't think that you should use these, right? So you should just use and, or, and not, right? So these are the basic operators. Okay, these are the basic operators. So basically that pretty much sums up chapter 9 as well. Is there any questions from this chapter? SQL, databases, anything? Oh, one more thing. All SQL queries end in a semicolon. Remember that. SQL queries end in a semicolon. Okay, so you should remember to add semicolons to the end of the statements. How to use between and like. I'm unsure if it's in the syllabus. Let me just see. I don't suggest. Yeah, no, it. I don't think it is in the syllabus. So just okay. I'll just remove that. Don't worry about between and like. Just use and or not. Okay. Can we say like in stock is equal to nest? No, no, no. Okay, no. We'll get this in the past papers as well. We're gonna get this into the past papers as well, but you can't do that. You have to specify yes or no. If they have, or we is it more safe to say in stock is equal to yes? You would add the commas with it. Yeah, sorry, the what do you call it? The quotation marks with it. Okay, we're gonna get into this more when we get to the past papers, but yes, okay. My CS sir said it doesn't matter. You can listen to him, or you can trust the marketing scheme. It's your own choice. All right. So that's basically almost about it. Let me just fix up these notes real quick. Get rid of this red because it's really triggering my OCD. And just write down your questions. I'll get to them in a sec. Let me just fix this so my OCD doesn't kill me before the session does. Okay. Okay. All right. Okay. There we go. So, any questions? Display name. Okay, so first of all, you should do order by ascending. Okay, so you should write the full thing, order by ascending, not just order by ASC. Okay, you should not use this order by ASC. They specifically said that in the. I remember reading that in the 2024 syllabus change. So you should use order by ascending, right? So don't just use ASC. Isn't it descending by default? It's better to you write the whole thing. Okay, it's better to write the whole thing. So let's take a 5 minute breather right over here. I need to go pray Maghrib Salat as well. But yeah, can we do it in alphabetical order? Yes, you can do that in alphabetical order. And okay, so the order by statement, I see some confusing. Um, listen, all you have to do in the order by statement is specify ascending or descending. Okay, you don't need to write any field name. You basically select the field name and you sort it that way. Okay, you don't need to necessarily write it. Okay, and we're gonna cover this in the past papers as well. So don't worry yet. Okay, don't worry about it yet. Okay, so yeah, that's basically it for chapter 9, and let's just take like a 5 minute break, and we'll be back in like 5 minutes to do chapter 7. Okay. in chapter 7. Like I said, we're not going to do any theory part, any logic part today. So no flow charts, no structure diagrams, just the theory part. The reason I had today's session, I was planning to do all of P2 tomorrow in one go, but the reason I had today's session was to get these annoying theory related topics out of the way, the small ones like Boolean logic, databases, and the theoretical parts of chapter 7 like the program development life cycle. So yeah, we're just going to do theory today. It's not going to be, we're going to be done within like the next 20 minutes. So today is probably just going to be like a 1 hour, half hour, 1.5 hour long session. So it's not that big, just a session to get rid of the ones that we don't need, right? To get rid of the stupid, annoying, small, mini, weird topics that are stuck in the center. Okay, so I keep seeing some questions regarding SQL. So yes, you have to write SQL in you have to write SQL capitalized, and you should use the whole word. You should use ascending, or actually, I'll show you guys the syllabus. Okay, since a lot of you just need to see the syllabus. So this look at the syllabus order by. Alright. So just go open any marking scheme and you'll see that it uses ascending or descending. You can write ASC, you can write DESC. You can write ascending, you can write descending, so don't need to worry about that a lot. Okay, so you by default for up to the 2026 syllabus, yes, it is ascending by default. But after 2026, 2027 onwards, I believe, you have to specify if it's ascending, right? So you can see that in the syllabus change as well. Sorry, after 2026 onwards, not 2027, 2026 onwards. Okay, so that is okay. That's chapter 9 covered. So let's move on to the theory part of chapter 7. So we're gonna be done with that within like the next 20 minutes, which is also when we'll conclude the session. So not a big session, like I told you guys. I just want to get rid of the weird logical part. So it's just going to be program development life cycle that we're going to talk about. We're going to do all of structure diagrams, pseudocode flow charts, all of that stuff. We're going to do that tomorrow. Okay, we're not going to cover Python. That's way too extensive. So yeah, let's just talk about program development life cycle, and we're going to be done with that in like 10-15 minutes, and then we'll conclude today's session. Right. So when we talk about program development lifecycle, PDLC, the program development lifecycle, we can talk about 5 main stages. Okay, there is the analysis stage, there's the coding design stage, there's the coding stage, there's the testing stage, and then there's the maintenance stage. Okay, most people do not know about the maintenance stage. This is something that is part of the PDLC. Okay, so let me just so when we talk about analysis, we have a few things in mind. First of all, we have to talk about the definition of analysis itself. It's basically part of the PDLC, which is a process of investigation leading to the specification of what the program is supposed to do. In less complicated the analysis stage is basically the stage in which the people decide, oh, we want our program to do this. Okay, that is basically what the analysis stage is. And there are two things that come under the analysis stage. These are the abstraction and decomposition. Okay, the two keywords that you should know. These come under the analysis stage. These are the part of the analysis stage. So abstraction is that any unnecessary details, the definition of abstraction, any unnecessary details are removed and only the solution is kept, and only the solution to the problem is kept. Decomposition means to break down a complex problem into smaller problems, making it easier to deal with. Okay, so That's basically what decomposition is. Then you have the design stage. Okay, let me. What is wrong with Grammarly? What the hell? Unnecessary. Is that not how you spell unnecessary? Unnecessary. Okay. Then you have the design stage. Okay. This is the part of the PDLC which uses program specifications from the analysis to show how the program should be developed, to show how the program should be developed. So some examples include pseudocode. It includes top-down design. It includes structure diagram. It includes flow charts. It includes user interfaces. Right, I might be a bit wrong here, so let me know if I'm wrong, but I'm pretty sure it includes all of these other interfaces. Let's talk about each one of these respective definitions. So pseudocode is basically showing an algorithm, a method of showing algorithm. Top-down design is basically a method, breaking down of a computer system into subsystems, Then you have structure diagram, which is a diagram that shows the design of a system in a hierarchical way by dividing it into subsystems. Flow charts, a diagram that shows the steps required for a task. Okay, I would say that when they do ask you for things that are used in the design stage, you say top-down diagram, structure diagram, flow charts, and if it's like 4 or 5 marks, then you use to look and design. Okay, structure diagram is in AS. No, it's in O-level CS as well. It's in IGCSE CL as well. PDLC is the program development lifecycle. I'll write the full form. Program development life cycle. And overall, structure diagrams is pretty easy. Structure diagrams. Yep. Right over here, the syllabus. I sent the syllabus screenshot in the chat. Okay. Yeah, remove user experience, remove user interfaces, just these 4 examples. Okay, there we go. Then you have coding, which is the writing of the program. Okay. The writing. Oops. Let me add a few spaces as well. Okay. The writing of the program. Okay. The writing of the program. Yeah. And then you have, you should also know what iterative what iterative testing is, and we're going to get into this more in chapter 8. There's also testing itself, which is basically systematic checks done on a program to make sure it works under all conditions. I think black box testing, etc., was AS syllabus. So I'm not going to go over that. I'm pretty sure that was AS syllabus. Yeah. Yes. Okay. Yeah, that is AS syllabus. There's a structure diagram question in 047822/further mechanics /webmars. Send that question to me in DMs, or send the paper to me in DMs, and remind me when we start past paper sessions. Okay. We'll do that paper. Okay. That is what the PDLC stages are. What else do we have? What else do we have? Do we have anything else? Okay, yeah. Iterative testing, we should know the definition of iterative testing. Iterative testing is basically when modular tests are conducted code is amended, and tests are repeated until the module works as expected. I guess so you should know that as well. Then you have what else? I think that's it for PDLC. Okay, so decomposing a problem. Okay, so one thing that you should know is that a computer is made up of subsystems. Okay, every computer system is made up of subsystems, which is made up of further subsystems, which is where these diagrams come in mind, right? The top-down design and structure diagram. Uh, Also, I realized that I've made another error. Abstract top-down design is not part of the design thingy. It's more, which is a computer and subsystems. The top-down design is basically used to show all of these subsystems. Okay. Somebody want to restart? We can't restart. I'm sorry. Is this ChatGPT? What? What is ChatGPT? Okay. Oh, you mean that? Okay. All right. So when it comes to decomposing a problem, okay, decomposing a problem. So each problem needs to be decomposed into its component parts. Into its component parts. These are respectively inputs, processes. Okay, so you should know these inputs, processes, outputs, and storage. Okay, so input is basically the data used by the system that needs to be entered. Okay, processes is the tasks that need to be performed using the inputs, tasks that need to be performed using the input. Outputs is basically information that needs to be displayed, and storage is data that needs to be stored in files for use in the future. Okay, so you should know how each one of these are. Now let's talk a bit more on structured diagrams, flowcharts, and pseudocode. So the way a structure diagram works, let me go back over here. Okay, so we understand that a computer system is broken down into further systems. Okay, so for instance, like this. Okay, and then some of these are broken down further into more subsystems. Okay, so it kind of works like this. Okay, so let me just boop, boop, and then we can make an arrow as well. So this arrow goes over here, this arrow goes over here, this arrow goes over here. This is a really rough structure diagram. Usually you should do something like this, where the arrows are actually much neater and squarer, like that, but I am too lazy to do that. Then you have like this, then you have like this. One of the most common examples of a structure diagram would be an alarm clock. Okay. Features does have? It has a, what does it have? It has a setting alarm feature, setting alarm feature. It has a check time feature. And then it has a sound alarm feature. That's what it does, right? You set an alarm, then you check time all the time, and then when the time goes by, there's and when the time passes, then you sound the alarm. Okay, so when you talk about setting alarm, there's a few more things that you can write. You can write set time, and then obviously turning alarm on and off. You can also write snoozing, so snooze slash on slash off, blah blah blah. So there's a bunch of subsystems. So basically, this is what a structure diagram looks like. It's a bunch of boxes with arrows. Well, at least in the IGCSE syllabus, it's a bunch of boxes with arrows. So let me just boop. Let me just put this over here, right over here. Never mind. Where did it go? Let me just. Oh my god, why is this so annoying? sometimes they may ask you to make a structure diagram. So in that case, you must think yourself how the program could work. Sometimes they do give you hints, so make sure when we do past papers, you're gonna realize what I mean by this. But right now, this is how the structure diagram looks like. Then you have flowcharts. Okay, so let me talk about flowcharts a bit more. We gave the definition of flowcharts over here, but let's talk about flowcharts a bit more down here. Let's talk about their different components. So just like how pseudocode has a bunch of different commands like input, output, blah, 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 flowchart also works like this. So first off, we have the beginning and the end. Where is it? Okay. So first off, we have the beginning and the end symbols, which honestly, I'm going to copy from my old notes if you guys don't mind, because it might get too much work. Okay. So we have the beginning and the end systems kind of like this. Okay. So you have the start and your end systems. Okay. So these are the beginning and the end. You can write begin, ending, but we use start and end. Then you have processes, which is basically a square box. And this program is so autistic, it doesn't have a square box. So I'm going to make a square box myself. Zoom in. Let's make a square box. No curved edges, please. This is what a process looks like. So for instance, if you want to give a value to a variable. Okay, so for instance, if you wanted to say that C is equal to 1, okay, that is what a process looks like. C is equal to 1, for instance. So this is what a process looks like. I'll also like write these down on side by side. Oops. So you have big start / end, which are basically the terminator flowchart symbols, apparently symbols. Then you have the input process. Oops. Process symbol. Then you have the input output systems, which are basically a parallelogram. Lovely. This doesn't have a parallelogram either, so it looks like this. Boop, 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 and boop. Okay, and this is basically used to take input / output. So it looks something like this. So input A or output A, whatever you want to do. So basically this is used for input or output. So let's just boop. Yeah. Let me just input / output. Then you have decisions, output. Then you have decisions. So that's just a diamond. Thankfully, they have a diamond over here. So it's goes something like, for instance, A is greater than B. All right. And then you must have like two lines that are going out of it. So two flow lines. These we call these arrows flow lines. So a case for yes, a case for no. So you say that yes, and you say no. All right, and then they further proceed down the program. So let me also copy this. We call this the decision symbol. Oops. Decision. What else? Right. So flowcharts. Let's this is what you need to know about the syntax for flowcharts. Let's also talk about the just a second. Let's also do a few examples of flowcharts. Okay, let's also do a few examples of flowcharts. Uh, all right, let's take an example. Okay, let's take an example program. Let's say that I want to make a program that, let's take the most basic example that can come to our mind. Let's say that I want to let's say I want to make a program that takes in 100 values and outputs their sum, averages, and averages, and average. Okay, pretty simple. Pretty simple. So obviously, just like I told you guys before, we have a start and an end. Okay, so if I mess up the syntax in flowcharts, how would you recommend? So this is don't make flowcharts with pens. Make it with pencil, and then when you're done with that, you write over it with a pen. Okay, or make it on a rough sheet. If you really want to use pen, make it on a rough sheet first. You can ask the invigilator for an extra pen and make it on that, and then you obviously do it. Okay. Okay, so whenever you're working with a flowchart, you have a beginning or an ending. So we're gonna go with a start. Okay. Now it said that takes in 100 values. So obviously this means that we have to be looping. Okay, this obviously means we have to be looping, and in order to do a loop, we do count. Okay, we do count. So when we do this, we're gonna make a flow line, and we're gonna initialize a variable to 0. Okay, and that variables, I'm just gonna use a rounded corner. Just make sure that you're using like sharp corners. It's not that big of a deal, but like Cambridge is Cambridge. They cut marks even if your answer is wrong. Okay, so I'm gonna initialize a count variable to 0. Okay, and what we're gonna do is we're gonna loop over our code until 100 values are reached. Okay, until 100 values are reached. So we're gonna go down and poop. Okay, we're gonna input our values. So I'm gonna make a parallelogram, or I'm just gonna copy this parallelogram from up here. Okay, I'm just gonna copy this parallelogram from up here. I'm gonna bring it down here, and we're gonna make it smaller like this, and we're gonna change this to input value. And let me just make this a bit small. Okay, now one more thing, in order to calculate the sum and the average, obviously we need a variable to count up the sum and average. So we're going to add a sum variable over here. So we're just going to say that sum is also equal to 0. Okay. And now what we want to do is we want to make another process that adds up all the values together. Okay. So we're going to make this, and we're going to make another process that basically adds up all the values together. So we're going to say sum is equal to sum plus value. And we're also going to increment count by 1 in the same thing. Okay, so count plus 1. Okay. Now, how does a conditional loop work? It obviously checks the condition, and if the condition is met, then it goes back. Okay, so we're going to add a decision symbol. Okay, I'm going to show you guys how loops work as well. So we're going to add a decision symbol, and we're going to see is count greater than 100, which means if it is, then we're going to end it. We're going to calculate basically, right? We're going to say we're going to calculate. We're going to deal with this in a second. So if it is, then we're going to deal with this in a second. But if it isn't, then we're going to go back to the start. Okay, we're going to go back to the start. And we're not going to go back to over here. Okay, make sure that we don't make that mistake. We're going to go back to the inputting. Okay, because if we go back to over here, then that's just going to reset our count, and that's going to reset our thingy magic. Okay, so yeah, and then if the loop has passed, then we're going to calculate the average and output it. So we are going to say that we're going to make a statement: average is equal to sum over 100. And then we're going to output sum and average. So we're going to make another parallelogram, or let me just copy this one. Let me just copy this one, paste it over here. And now we're going to output sum, average. Again. Let me just make this smaller. Let me just make this AVG. Okay. And then obviously we're going to come to an end. Okay, we're just going to come to an end. Pretty simple. This is how a flowchart works. Okay, so hopefully the logic is understandable. You should know how to do looping in flowchart, just like how I did. Remember, there are no greater than equal to 100. Yeah, greater than equal to 100. Yeah, sorry, my bad. But yeah. Okay. Yeah. Okay, this is how looping works. Okay. Then can you upload the video? Yeah, of course it'll be uploaded before 20th May. But this is how a flowchart works. Okay, you have your start, you have your end, you have your processing, you have your inputting, outputting, you have your looping, you have your flow lines, and yeah, that is basically how an example flowchart looks like. Yeah, okay. Let me copy this and let's paste this here as an example. Oops. There we go. That is basically a flowchart looks like. Okay, any questions about flowcharts? Flowcharts, structure diagrams, anything at all. What is the purpose? It's used in the design part. We're gonna do the taste table. We're gonna do the trace table. I was thinking of doing pseudocode first because there's trace tables. Trace tables are part of pseudocode as well. But we can do trace table first actually. We can do trace tables first. Yeah, because like this is a pretty long thing. How do we use this subroutine? Oh, okay, my bad. I forgot. Subroutines. Okay. So there is another thing. Just a second. All right, I'm back. All right. So let's just say that I have this procedure, okay, somewhere in the code, and it's called ateeb, and I want this flowchart that we have over here. I want this flowchart to call me. Okay, so what I can do is that I can implement one of these subroutine features. Okay, I'm just gonna bring this a bit more down. I'm gonna remove this arrow. What I can do is I can implement this. Okay, I can add a box which has these bars at the end. Okay, and what I can do is that I can add an arrow to it like this, and then an arrow to it like this, and I can call the procedure. I can say, where is my text? I can say call quality. Okay, since that was my procedure. Okay, so it's kind of like this. Okay, like this. I don't think this has ever come up on a paper before, so we don't really know the syntax of it, but this is what I assume it is. Okay, this is what I assume is that it is, because most of the other things are just pseudocode. So we're just gonna make this based on pseudocode as well. But basically, it's used to call. Subsystems are basically a system broken down into more systems, which are broken down into more systems. Procedures, like how when you're writing pseudocode, you make procedures, right? You make something that takes an effect in the code. That's basically what a subroutine is. You can think of it like that. Yeah, so a subroutine is kind of like a procedure. That's how you can think of it. And yeah, this is also a symbol that I forgot to add. But yeah, that's also symbol. Okay, let's do taste tables. Procedures, we'll cover that when we go over pseudocode. Do you have your CAI on Wednesday? Okay. Okay. You should really know what procedures are. If okay. Anyways, I'm just looking to see if there's anything else besides trace tables that we have to do before we move on to pseudocode. Uh, Let me also refer to my old notes. No, like trace tables from pseudocode, it's pretty simple. I'll explain to you guys trace tables. It's not that hard. You just have to, put your finger on the chart and you have to go through the chart. I'll explain it. Let me just make sure that there's nothing else that I'm missing? Oops. Before we move on. What the hell? Why did chapter 6 open up? Okay, so we did this. Pseudocode, a shit ton of pseudocode. That is. Okay, test data. Yes, of course. Test data, trace table. We'll do validation and verification at the end. And from chapter 8, okay, test data and pseudocode. Okay. Let's talk about test data first. Okay. No, I opened chapter 6 accidentally. Okay. Sure. So, can you also do a past paper question for traceable? Of course, we'll do past papers. Okay. Sure, we'll go with test data. Okay, so test data, a set of test data is all the items that are required to work through a solution, okay? A set of all the items required to work through a solution, a set of test data. Also, guys, I've said this before and I'll say it again. My notes are not MS based. When you guys want MS based notes, something that will actually go forward as a marketing scheme answer, notes that we were talking about before, which were either the Elysian notes or the pub notes. Those are way better notes if you want revision. I do these sessions to explain concepts, not to make MS based notes. Remember, computer science is mostly about just matching keywords. It's literally just matching keywords if you know the test slash normal test data. Okay, you have boundary test data. You have abnormal test data. What else do you have? Let me pull up the syllabus. Extreme test data. Okay, so expected slash normal test data that are accepted by the program, and abnormal is obviously values that are rejected by the program. So in our case, we're gonna say that our program accepts the values 1 through 100 exclusively. Okay, we're gonna say that our program is my voice audible? Hello. All right. Okay, let me know when it lags. I think my Wi-Fi is glitching up again. Okay, so yeah. So these are pretty simple. So an example of normal test data in our case would be something like 50, 60, 65, 56, blah, 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 so on and so forth. Whereas abnormal would be something like 150, 250, negative 520, the character ABCD. Okay, something like that. Then you have boundary test data. Now, boundary test data is more like a set of data, set of values. Okay, these are the boundary values. So in our case, it would be 0. It would be 1 and 2. Why would it be 1 and 2? Because our data takes in values from 1 to 100 exclusively. So the boundary is going to be 1 and 2 because 2 is going to be accepted and 1 is going to be rejected. Because again, it's exclusively. Okay. If this was inclusive, then we would go with 1 or 0. But boundary data basically means that one value that is at the boundary that will be accepted and one value that is at the boundary which will be rejected. So for instance, a more visual example of this would be something like we have our datas we have 1, 2, 3, all the way over to 100, 99, 100. Since our data is exclusive, the data that is accepted is this. So what did we do? We took one value that is going to be accepted at the boundary and one value that is going to be rejected at the boundary. Okay. Then you have extreme test data, which is basically the maximum values, the maximum and minimum, or the values that the program can take, that the program can accept. Okay, so in our case, that would be 2 and 99, because again, this is exclusive. Okay, inclusive versus exclusive. Exclusive means that any values that are between this, so 1 to 100 exclusive just means 2 to 99 inclusive. Okay, so exclusive means excluding the values that have been mentioned, and inclusive means including the values that have been mentioned. So you should know that as well. Well, yes, 1 and 100 are rejected because this is an exclusive now. If I said inclusive, then they'd be accepted. Okay, if I said inclusive, then they'd be accepted because then one is inclusive, but I'm saying exclusive. Okay, so you should know the difference between inclusive and exclusive as well. Do not make that silly mistake. What is boundary? It's the data, it's the set of data that is at the very edge of the acceptable values. One value is acceptable, one value is rejected. That, like I just visualized to you guys. So for instance, this was our test data. This box is the values that it can accept. So boundary data would be, for instance, this value and this value. One of them is rejected, which is 1, and 2 is going to be accepted. Kumail Nanjiani. I have no clue who that is. What's the difference between boundary and extreme? Extreme is the values, the maximum and minimum values, the very edge values that the data can accept. Boundary is a set of values that is at either edge of the data, right? So for instance, boundary was this, right? So this one was accepted, this one was rejected. This set of value is boundary, whereas extreme would be this value and this value, which is the maximum and minimum value that can be taken by the program. All right. Then we have, I think, trace tables, right? Trace table. Okay. Trace tables. Trace table. Okay. Any questions, by the way, from test data? Any other questions? Extreme and boundary test data, please. Do not mix it up. When we go over past papers, you guys are gonna see a bit more. Then we have trace tables. Trying to find a good definition for trace table. Gunshots. I have no clue where you're hearing gunshots from, man. Okay. All right. So a trace table is used to record values in an algorithm after each step. Or you can say documentation of an algorithm, documenting the steps of an algorithm. Whether that's flowchart, whether that's pseudocode, blah, 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 whatever that is. Okay, then there's also the definition of dry run, which is basically dry run, a manual process of running the algorithm by hand. Okay, so if a variable changes multiple times in one loop iteration, how do I write each change on a new loop? What do you mean? Can you explain this a bit more? Can you explain your question a bit more? But yeah, so you have dry runs and you have trace tables. Honestly, we're gonna do a few questions of this. Let's do like 3, 4 questions of these things so that we can fully understand this before we move on to pseudocode. Because pseudocode would then be the last thing that we have. And then we have steps to write an algorithm. So you should also know these steps to write an algorithm. Okay. So first of all, of course, you know the PDLC analysis, design, blah, blah, blah. But when you want to write an algorithm, you need to make sure that the problem is fully specified. Okay. Then you want to set up processes, inputs. You want to decide on how data is obtained. Actually, I think I'll just pull these up from last year's notes. I haven't done this for paper 1 because paper 1 does have a lot of content on it, but paper 2 is pretty freaky. But Steps to writing an algorithm is that you have to make sure the problem is understood. You have to break down the problem into subproblems, which was what? Which was decomposition. Okay. Then you have to identify data and its data types. Then you have to decide what construction method you want to use, like pseudocode, flowchart. Uh, then you have to construct it, and then you use test data, right? So basically, if you notice quickly, then this is basically the the PDLC. Okay, so this was the analysis stage. This was what? This was the design stage, right? This is the design stage. You breaking down the problems, identifying data and data type, making type tables, blah blah blah. Then you had the coding stage, and then you have the testing stage. So it's basically the PDLC with a bunch of yap. That's the steps to write an algorithm or design an algorithm. Any questions before we move on to pseudocode? We're gonna take a 5 minute break. I need to pray, and then we're gonna be back, and we're gonna do some trace table questions, and then we're gonna move on to pseudocode. Extreme. Listen, boundary is a set of data. It's basically one value in it is gonna be one that is accepted, and one value is gonna be rejected. Okay, that is what boundary data is. It's a set of values. Okay, at the very edge, at the very edge. So if I, yeah, exactly. There's sets of data. Okay, so boundary data, we're gonna do a past paper question on this. I'll try to find a past paper question on this so I can show you the marking scheme of how it works. One of the values is accepted, one of the values is rejected. Yes, for my example, it's 199. Okay, for my example, it's 199. How much time during exam should we invest on trace tables? 5 minutes. Honestly, I'll tell you guys how to manage your time on the paper as well at the end of the session when we do the past papers and guide you guys on what to do and everything. But we're gonna take a 5 minute break now. We're gonna be back at 30. I need to go pray. I'll be back in at 30. All right. Okay. Let's. All right. So okay, let's do one question of so what do you say, trace tables and of logic circuits. Okay. I'm gonna pull this out from the paper that I gave, May June 2024, paper 2-2. Let's solve this on this area right over here. Okay. All right. Okay. In May June 25, there was an algorithm and traceable for palindromes. You. Okay. So we have this question over here. Let's start off with the logic circuit. So, uh, a word problem. Lovely as always. Pretty simple. Uh, okay. So I'm taking these questions from May June 2024 P22. Uh, what do you mean? Can I trust your notes again? What? Okay. All right. So when I talk about word problems, what did I tell you guys? You want to do x is equal to when all the values are 1. So a logic circuit is to be built to control the opening of a safe used to store money. There are two keys A and B with a time switch C. The safe can only open if both keys are used and the time switch is off. So used, off, and it's gonna be X. Okay, so like I said, you guys have to highlight the cases when it's 1, okay, which I just did, and then we're gonna write that down into a logic expression. So I'm gonna make an error, and I hope you guys can see what the error I make is, and then I'm gonna correct the error as well. So I'm gonna ask you guys what the error is actually. Because this was an error that I almost made while I was doing the CAI. So what would the expression be? Like I said, point out all the values which are 1 and add naught for the values which are not 1. So this, and this. Okay. So where did you get in P2? I didn't get my component marks. I calculated myself afterwards and I'm pretty sure I had a near 75. I think I lost 1 or 2 marks. I know that. Okay. What was I saying? Yeah, okay. So we're gonna write A and B because they're just ones, and then we're gonna say and not C. Okay, pretty simple. Like I said, you guys have to uh, do the ands of the values. Okay. Uh, all right. Now, what is the error here? What is the error here? Can anybody tell me what the error is here? X is missing. Exactly. X is missing. Okay. You gotta write X. They said the safe can only open, so they're mentioning the value of X as well. So you need to write X. That way you get 3 marks. If you just wrote the expression, you would have gotten 2 out of 3. Okay, so make sure to write X. Can you write X on the right hand side? It's there is one statement that I used every single time that I've given a CS session, and that is don't make stupid mistakes. When you can write it on the left side, why do you want to ask about writing it on the right side? Just if you accidentally write it without using the X and then you remember it later on, cut it, write it again. Or ask for an extra sheet and write it on there. You can ask invigilators for an extra sheet. Don't be scared to do that. Ask them for an extra sheet, write down the part name, and then put the thingy. Okay, they give you extra sheets. Okay, wait, where is this? I'll show you guys. One sec. Where is it? Yes, we can. You can ask for extra sheets. You can ask for extra sheets easily. I'll show you guys something. 1 sec. That's what I did. I asked for extra sheets, and then you can cut it. You just raise your hand for the invigilator. They're supposed to give you extra sheets. It's their job. You just raise your hand and you ask them for rough sheets. I'll show you guys how that works. Wait. Uh, Let me show you guys my A level paper, AS level paper. Just a second. I showed this in P1 as well. Or was that the AS session? I showed this in one of those sessions. I forgot which one. Why was that so vehement? Where is the script? Just a second, guys. Just a second. Also, they do have like blank space at the end that you can use to write answers. Or, bro, you have to persist. I'm pretty sure they do. Wait. They gave me an extra sheet. I remember my CI. They gave me an extra sheet, both in AS and in O3. There is no way. Examination conditions. Cambridge. I just opened this the other day. What was it, bro? I forgot. Shit. Let me find this document. Wait. No, wait. Hold on. There's the. Just a second. But not in mine. They said use extra sheet, and my extra sheet was filled up. The fuck? Why was I so lucky then? Okay, then you just cramp it at the end of the blank page, or do it with pencil, or maybe beg. But wait, there is a document that I opened the other day. Let me confirm it from there. I opened the document that British Council sends to each one of these centers, and I cannot find it. But I kind of lost it. But let me just see if I can find it. They send a document to. That's why I say use a pencil on the 15 marker. Just a second. No. Use a pencil and then change that pencil. Obviously, use a pencil and then rub it off and write with pen. That's what I said. That's what I meant. That's what I meant. Use a pencil and then rub it off and write over it with a pen. That's what I meant. Not don't attempt your paper and pencil, guys. Don't attempt your paper and pencil. Uh, uh where is it, bro? I swear to God, I saw it the other day, and I just opened it for no reason at all. But now I'm realizing that it had actually a reason. But okay, I'll find that side as we do this. But okay, so creating the truth table is pretty easy. First, we're gonna write the sequence for A and B. So A and B. Okay, so first we're gonna do that. Okay, so that's obviously just gonna be 0, 0 is what? 0. Oops. How do I? Okay, 0, 0 is 0. 0, 0 again is 0. I'm just gonna add a dot for 0. 0, 0, 0, 0, and then 1, 1. And then we're gonna do not C as well. How can I not make this stupid thing? Okay, never mind. So not C is just gonna be 1, 0, 1, 0, 1, 0, 1, 0. And then we're gonna add both of these to get 0, 0, 0, 0, 0, 0, 1, 0. Pretty simple. Which if you go up here, and you can see that it can only open if both keys are used and the time switch is off. So the only case where it is 1 is when both keys are used and time switch is off. Okay. So do remember that. Reduce the thickness. I can't figure out how to reduce it, but it's okay. As for the question about the if we can use extra sheets, I'm trying to find the handbook that these give out that they give out to freaking centers to make sure that what I'm saying is not. I'm pretty sure they're supposed to give you extra sheets in IGCSE. I remember I got O levels. In O levels, I got extra sheets. So uh, pretty sure they're supposed to give you mate. But you have storage. I don't have much more time. Yeah. Okay, and then we have. Let me know when you're recording. When how long can you record? Because I'm pretty sure that's gonna go on for another 3 hours. Maybe it depends on centers. No, it shouldn't depend on centers. Now, Cambridge is you're appearing for the British Council. You're not appearing for individual centers. You're appearing for the British Council, and as per the British Council regulations, if one candidate gets extra sheets, that means that you're also obligated to get extra sheets. Cambridge. Additional, I think this one was it. I think this one was it. Yeah, okay. I'll send this link in the chat as well. If I go over to, okay, 0478. How do we quickly how do we quickly memorize the trace table logic things? Just know the concept. Just know the concept. Know the concept that not means switching them, or means adding, and means multiplying. By the way, if one then one. XOR means if same then false. Just go through the notes. And uh, okay, there's probably somewhere over here. I'll look at this afterwards. I'll look at this afterwards. Yeah, no, I saw this. It says not applicable for this component, but it says not applicable for every exam that I've ever given and gotten extra sheets for. So I'll talk to a teacher after this and I'll let you guys know at the end of the session. I'll message a teacher and I'll let you guys know at the end of the session. He probably knows more than I do. Let's not waste time on this though. Let's not waste time on this. Let's pull up the next question. So the next question is trace table. Nice. I know you are supposed to get extra sheets. It is your human right to get extra sheets in the examination. I've never heard of anybody who got rejected for extra sheets. Then you have the table. Okay, so this is a beefy flowchart, so I think it'll be a fun one to solve. So, guys, the main thing that you need to know about trace tables, trace tables are really, really, really simple. You just have to go slow with them. Okay. Uh, wait. Why isn't this? Why aren't you importing? Dog. Why did you import 3 times? Okay. Trace tables are really simple. You just have to go slow with them. You gotta treat them gently. Okay. So, how do you treat them gently? Okay. So, I would suggest that you guys put your finger on the trace table, and as you go down, write down everything that's happening. Okay. So, for instance, you start over here. Oops. You start over here. Okay. You write down what's happening. What happening? Okay, so we know okay A is becoming false. Oh my god, this is so bad. I think I'll download the paper. Maybe it's better to answer on Mac. Just a second. Let me see if it's better to answer on Mac. Let me see if it's editable. Please let it be editable. Please let it be editable. Okay, it is editable. Okay, perfect. Okay, I'll just share my. Okay, is my screen visible? Is my voice lagging? I think got disconnected. Yeah, I think my Wi-Fi is lagging. My Wi-Fi is lagging right now. Just give it a second. Let me restream. Can you see the stream now? Okay. All right. So as I was saying, you want to put your finger on the flowchart, okay, and you want to go down from there. So the first statement, what happens is that A is false and B is 1, right? So I'm just gonna write down A is false, B is 1. Okay. Then we're gonna go down. Is list B greater than list B plus 1? Is it? Is list 1 greater than list 2? It's not. So we're just gonna go down and it says B is equal to B plus 1. So we're just gonna increment the value by 1. And then we're gonna see if A is equal to true. It's not, so we're gonna go back to the top. Okay, and then it becomes A is false and B is 1 again. Wait, what? Oh, sorry, is B equal to 5? I didn't see that. Okay, so is B equal to 5? It isn't, so we go back to the top and then it checks it again. Is 2 greater than 3? Is list 2 greater than list 3? It isn't, so it increments B by 1 again. And then it goes on. What is the relation? Why is my Wi-Fi lagging? Can you guys hear me right now? Why are my texts not sending? Can somebody reply to Puppy asking about the sheets thing? Can somebody reply to Puppy about asking about the sheets thing? My Wi-Fi is just not working. My Wi-Fi has decided to give up. Anyways, so yeah. So it's gonna increment by 3 and then it's gonna see, is list 3 greater than list 4? It is. So what it's gonna do is gonna put T as list, what's it gonna put in T? It's gonna put T list B. So 20 is gonna go into T. And then list B plus 1. Sorry, 15. Wait. I think I messed up. Wait, let me restart. I think I messed up. Let's go back. So we're gonna go back. We're gonna start from here. So A is false and B is 1. I misinterpreted the sign. Okay. So we're gonna check. Is list B greater than list B plus 1? Is 15 greater than 17? It isn't, right? So we're gonna put B into T. So we're gonna put 15 into T. And then we're gonna make list 2 15 and we're gonna make this 17 because that's what these statements are. And then A is gonna become true. Okay. And then B is incremented by 1, right? Right over here, B is incremented by 1. Is B equal to 5? It isn't. So we're gonna go back to the top. Is list B, which is 15, greater than list B plus 1, which is 20? No, it isn't. So we're gonna do the T thing again. T is gonna become 15 again, and they're gonna swap again. So this is gonna become 15, this is gonna become 20. Okay. And then we're gonna go again, and this time B is gonna increment by 1 again. Okay, and A is gonna remain true. Okay, so true. Okay, because we did true again. Okay. Then then we have 3. Is list 3 greater than list 3 plus 1? Is 15 greater than 5? It is. So it's just gonna increment by 1. So it's gonna become 4. Is list 4 greater than list 5? It is not. So it's gonna swap again. So it's gonna become 5, 9, 5. Okay, because that's what we're basically doing here. We're swapping them by using the t variable. Then it's gonna become true again, and then it's gonna increment by 5. Okay, and then it's gonna read this condition: is b equal to 5? Yes. Is a equal to true? Yes. So it's gonna go back to the top, and a is gonna become false and 1 again, and then it's gonna go over the entire thing again. Okay, it's gonna say is is list 1 greater than list 2? It is not, so it's gonna swap again. Okay, so it's gonna swap again. So this is gonna become what, 17? This is gonna become 17. Sorry, this is gonna become 20. This is gonna become 17. And then it's gonna increment all the way till 5 again, because then there are no more swaps. It's gonna become 2, 3, 4, 5, because the list is now in order. Okay, and then it's gonna see, is a equal to true? Sorry, right over here a turned true as well. Okay, so is a equal to true? It is. So it's gonna go back to the top, and a is gonna become false again, and b is gonna become 1 again. Okay, and then it's gonna do the whole thing again, but this time it's gonna realize that, oh, it's sorted, so it's just never gonna go over to this part, which means that it's just gonna keep on incrementing. So it's gonna become 2, 3, 4, 5, right? Because b is equal to b plus 1. It's just gonna keep on doing this, and it's not gonna swap anything because it's in order already, and eventually it's gonna stop. Okay, I know my explanation was a bit very confusing, yeah, but honestly, trace tables are like that. But the biggest advice that I can give you guys is to take your finger, put it over here at the start of the algorithm. A was false, B was 1. So that is why I wrote A is equal to false right over here. I wrote A is equal to false, B is equal to 1. And then I brought my finger down the flow line and I checked this condition. Okay, it is false. So what happens when it's false? My finger went over here. T become list B. So that is what I did. I made T list B right over here. And then I made my finger go down. Okay, it became list B, and then there was basically swapping right over here. So that is what I did over here. Okay, there was basically swapping, so that's what I did over here. And then my finger went down, and then it became A is equal to true. So that's why I wrote A is equal to true over here. And then obviously B is, and then my finger went over here, and then B is equal to B plus 1. So I incremented B by 1 right over here. And then I checked, is B equal to 5? No, so my finger went all the way over to the top. You just have to flow with the flow chart. Flow with the flow chart. Let your finger flow with the flow chart. Literally. You just have to let your finger flow with the flow chart. That is the best advice I can give you for the trace table. List B, it just swaps the variables. It just swaps with the variables. Yeah, exactly. Just flow with the flow chart. Genuinely, the only way that you are going to do truth tables that are based on flowcharts, make your finger start at the start. Every time that a variable gets edited, write it down in the trace table. So here a variable got edited, 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 here a variable got edited. And then just make your finger follow the flowchart, follow the flow of the flowchart. There's arrows for a reason. That's literally what a flowchart is designed to do. Yeah, you can play it like a board game. Sure, play it like a board game. Just follow the flow lines. Let it flow. Go with the flow. Literally. A stars are gonna flow away. But yeah, this should be like an easy marker. How do we differ between lines in the trace table? Okay, so whenever you're gonna start a trace table, almost always you're gonna start from the second line, which is below the line that they initialize them for you. And then just go with your gut, honestly. Like, I'm pretty sure there is a special technique for it, which I do not know of. But what I used to do is that if a value got edited and I didn't have space to write it in the current line, I just wrote it in the next line. That's literally all I did. If I didn't have space to write the change in the current line, then I just wrote it in the next line. Will we like get a trace table and told to draw a flowchart using? No, no, I don't think that's gonna happen. The only way that's gonna happen is if you can identify from the trace table exactly what the code is. Like for instance, if the trace table is clearly a bubble sort, maybe they can ask you to make an algorithm on bubble sort. Maybe. But there's no way that they're gonna ask you to make some random ass algorithm out of a trace table. You can't even do that. I can't even do that because I don't know what's going on in the head of the guy who made the trace table. So it's not gonna be in the reverse. Any questions? The only reason they can use a trace table and ask you from the trace table is what is this algorithm, which they did in this question, by the way. They did ask, describe what the algorithm by the flowchart is doing. What is it doing? It made this array into what? 20, 17, 15, 9, and 5. What is this? This is bubble sort. It was bubble sort. And what was it? Bubble sort in descending order. So that's what you had to write over here. That's literally most they can do. You still don't understand the part of filling up the trace table. Okay. Uh, Alright, so okay. Listen, literally, you have to just remember one thing. You just have to remember one thing. Start your finger on the start mark. Put your finger physically on the paper. On the paper, physically. Put your finger on the start. Okay? Where does the arrow tell you to go? It tells you to go down over here. Put your finger down here. A is false, B is 1. Write this down. Write this down on the next line. After the initializing line. Write this down over here. Okay? Then, once you're done writing it down, go down here. This condition, is it true? Check, 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 check. Is list B, what is B? 1. B is 1. What is B? Right over here, we just said B is 1, right? So is list 1 greater than list 2? Is 15 greater than 17? It isn't. So now my finger is gonna go over to the no part. Then they said T is list B. Write this down, write this down, write this down. Wrote it down. Then they said list B is list B plus 1. Write this down, write this down, write this down. Wrote it down. Then they said list B plus 1 is T. Write this down. Wrote it down. And then they said A is true. Write it down. And then your finger goes from here to here. Oh, another variable change. Write it down. And then the condition, is B equal to 5? Is it? No, it's equal to 2. So you're gonna follow the no path and you're gonna go all the way, your finger is gonna go all the way over here and you're gonna repeat the process. Literally, literally, literally just follow the flowchart. Put your finger on the start, make it go, and every time a variable changes, write it down. Can you explain the list? We're gonna go into pseudocode and I'm gonna explain bubble sort in that. I'll explain it then, okay? Literally just put your finger at the start and let your finger flow with the waves, with the flowchart. That's just swapping. We're gonna go over what that is when we do bubble sort, don't worry. Uh, just, oh God, I can't even type. For some reason, my Discord's bugging out. Uh, Wait, do I still have the event maker role? Do I still have it? I do not. Nice. Okay, I can't. Can someone tell Puppy that some people are not okay? He's coming, he's coming, he's coming. Hey Puppy. Hey. Hey. Oh yeah, okay. I just wanted to confirm that some people were saying that they aren't able to receive extra sheets because the invigilators just don't give them. I just wanted to confirm that that's not the case. Because like I swear I remember during my O levels I got extra sheets. During my AS levels I got extra sheets. Some people are saying that the invigilators are like cram it onto the paper. It's an obligatory, right? It's obligatory for the invigilators to give them. Guys, fight for your rights in the exam paper. Tell them that it's an obligation. Exactly, it is rigged. Yeah. Yeah, you can always ask for extra sheets. They have to give it to you. If they ever ask you, then I'm gonna send you guys a British Council policy. Wait, there has to be one. Policy on giving extra sheets in CAI paper. There has to be a policy in some of their policies just for a bit. And what do you say? If they don't give it, then call British Council right now. Call them right now or in the morning and tell them that your center, you asked them for sheets and they didn't give it to you. Literally just call British Council and report that center. Simple as that. Just call British Council in the morning. Yeah, just call British Council in the morning and just be like, hey, my center, whatever your center code is, did not let you use extra sheets. Simple. Why is there a whole PDF that is public on what to say to candidates? Yo, that's so cool. My God, I found the CAI script document. Oh, I can't send the code. Freaking. I'm gonna rejoin the stream. I'm gonna restart Discord because my Discord is freaking out. Uh, and then we're gonna start off with pseudocode. Okay. I hope that so far you guys have no questions. I'm gonna restart my Discord. I'm gonna rejoin the community event thingy, and then we're gonna start pseudocode, which is the last thing, and then we're gonna move on to the past papers. Let's do pseudocode in 1 hour. Let's do pseudocode in 1 hour. Bada bing, bada boom.
What? Why am I allowed up here? This is crazy. No, no, no. Wait, wait. No, I'm not prepared for this. This is going in. No, no, no. I don't want this going into the recording. It's literally going into the recording. Get me off. Get me down. Get me. Get me down. Get me down.
It's okay, we'll edit your part out.
What you? Oh my
Go ahead. You signed up
No,
for this. Talking about it.
no, no, no.
Yeah, go ahead.
Get me out. Get me out. I'm gonna disconnect. Bye bye, guys.
All right, guys. Uh, Amazing, because I found the official policy that requires Cambridge to give you the continuation sheets. This is the official Cambridge exam dispatch guide for international centers. If you scroll down to page number 3, component specific materials for use in the exam room, continuation booklets, it specifically says that you need to make them available for each candidate and hand them out to candidates who require them. This is the official Cambridge statement. Ah, god damn it. It is required for the invigilators to give you that. I also sent a screenshot in the group chat for reference. Ah, god damn it. And if you if you already gave an exam and they didn't give you an extra sheet, call British Council in the morning and tell them that your exam. Oh, balki tomorrow is Sunday. Call them on Monday morning and tell them that your exam center, tell them your exam center code didn't hand you extra sheets for whatever paper you were giving. Anyways, let's move on to pseudocode now. Uh, yes, I'll represent you guys in court. Okay, let's move on to pseudocode. Yeah, continuation booklet as in 4-page booklet. Yep, exactly. All right, let's begin. So, sure, I'll call them for you, bro. Give me your exam center number. I'll call the British Council. I'll act as you, and I'll tell them that I didn't get extra sheets. Anyways, let's move on to pseudocode. So the basic thing that you need to know about pseudocode. Okay, variables, identifiers, blah blah blah. Do not send your center number in the chat. Delete that. Oh my god. Yes. Don't send your center in the chat. Oh my god. Stop sending your center number. Oh god. It's okay, gang. It's okay. It's okay. Oh man. Uh anyways, I was kidding. Shit. It's okay. It's okay. So the basic thing that you need to know about pseudocode is identifiers. Okay, let me pull up a pseudocode guide side by side so that I can go in a sequence. Blah blah blah. Okay, so we have identifiers, assignments, blah blah blah. There has to be 0478 syllabus. Okay. Yes. Yes. Okay. Let me scroll down to the syllabus part. By the way, guys, I heavily recommend that whenever you're trying to learn pseudocode, uh, refer to the syllabus. Okay, even whether you're in AS or you're in O3, there are a lot of pseudocode syntax errors. So refer directly to the syllabus because the syllabus directly tells you what and how you have to do it. Okay, so anyways, first off, you have identifiers. Where is my obsidian thingy? Okay, so assigning variables is pretty easy. You can use an arrow. So x is equal to 1, x is equal to true, x is equal to false, whatever it is. Okay, you have a bunch of data types as well. You have string, you have char, you have integer, you have real, you have boolean, you have date, and yeah. One more thing, I need to find the 0478 pseudocode guide. I think this is it. No, that is AS. I think this is it. Yeah. Okay. All right. There we go. All right. Yeah. So yeah. Like I said, there's a bunch of data types. Okay. Then you have to in pseudocode whenever you're assigning a value, then you have to declare it as well. Okay. So the syntax for declaring and the syntax for assigning. So the syntax for assigning is variable name, arrow, value. Okay, this is the syntax for assigning. Okay, and the syntax for declaring is like this. So declare variable name of type. Okay, data type. Okay, this is how you declare and this is how you assign in pseudocode. Okay, so we're gonna talk about arrays in a while. Okay, then I think you also have constants in 0478. Pretty sure you do. So in order to declare a constant, you have to do constant variable name is value. Okay. Then you have loops. Okay, you have loops. So for instance, you have three kinds of loops. You have a for loop, which is for x is for variable is from starting to ending. Okay, I'm gonna give you guys an example first. So execute next where. Okay, so how this works is that, for instance, if you have a code that goes like this for x1 to 5 and you do print x next x, this will basically print 1 2 3 4 5 because it's a count control loop. Okay, we call this a count control loop and it's going to go from 1 through 5. Okay. Okay, so then you also have a repeat until loop. So there's two types of loops when we talk about conditional loop. You have a post condition and a precondition. The names are pretty self-explanatory. A while loop, which goes like while condition to end while, is a precondition loop. Okay, so execute. This is a precondition loop. Whereas a loop like this, repeat until condition, this is a post loop. Okay, execute post condition loop. Okay, because post end pre beginning. Okay, so you should know all three of these loops. I'll also just copy this and paste this over here just for OCD's sake. Done. Okay, so yes, you should know all of these. Okay, you should know what variable name, how to assign variable names, how to declare variables, and everything. Precondition is basically when your condition is at the start of this loop. Okay, so for instance, in a while loop, our condition is right over here. An example of a while loop would be something like while x is less than 5, do print x, right? This is, oops, I added brackets, print x and while. So here you can see that the condition that we implemented is at the start of the loop. So hence, that's why we call it a precondition loop. Whereas here, if we do the same thing, repeat print x until x is greater than 5, then you can see this is a post-condition loop. Oh shit, my bad, I forgot. I think you guys are supposed to use output. Yeah, you guys are supposed to use output, don't use print. My bad, my bad. I keep confusing this. Okay, you're supposed to use output, don't use print. Yeah, thank you. Can you repeat the last part? Yeah, so when your condition, this is our condition, right? X is greater than 5. When it is at the end, then that's a post-condition loop. Whereas when it's at the beginning, that's a precondition loop. Can't we use both? You're gonna see in a while when we get to the validation part, you're gonna see why precondition and postcondition helps us like that, okay? Then we have conditional statements. Okay, conditional statements work like this. We have two kinds of conditional statements. So is loop executed at least once? It depends on your condition, man. It depends on your condition. If the condition causes the loop to execute, then of course it's executed. I'll show you guys what this means when we get to validation. Validation is the main part of our syllabus that involves loops. Then you have if then else conditions. Okay, if condition, then do something. Okay, then execute. Else execute something, and if. So an example of this would be if x is greater than 5, then output x greater than 5. Else output x less than or equal to 5. Okay, and if. Okay, so that is how that works. Then you also have case of. Okay, so case of is so you use an if then else statement when you have to compare multiple things to each other, when you have to use greater than equal to, less than equal to, blah blah blah. When you have fixed values for a single variable and you have to compare it, then we use a case of loop. Okay, so you sorry, a case of condition. So we say case of x. If it's a, then we're gonna output something. We're gonna output like Ateeb. Let's just say that x is something, the first letter of any name. Okay, and then if it's b, then we're gonna output area. If it's c, then we're gonna output caterpillar. If it's d, we're gonna output destructive sequence of nuclear codes for the United States of America. Then there's also an otherwise case. So if it's neither A nor C nor B nor if it's neither A nor C nor B nor D, then you can use otherwise, and then you can output something like I am stupid, I don't have an answer. Right? So that's basically what case of is. Okay, you use one variable and then you're comparing it to every single one of these possibilities. Uh Pretty simple, pretty simple. Then you have okay, we went over loops, we went over this. Okay, next you have arrays. I think right, you have arrays. Yeah, okay, you have arrays. Now arrays is a topic that is often considered complicated, but in my eyes it is a really simple thing to do. uh you're from Iceland. I'm from Iceland. Yeah, I'm from Iceland. But yeah, you can imagine Iceland. Sorry, you can imagine an. Okay, so if we imagine our variables as a bunch of buckets, right? We're imagining our variables with as a bunch of buckets, okay? And each one of these buckets have a value in them, right? So like for instance, this one has a value of 3, this one has a value of 4, this one has a value of 5, blah blah blah. Now these variables, an array basically means we're putting these variables on a table and we're giving each one of them a unique ID. So our IDs start from 0 or from 1, okay, whatever we declare it as, okay? So we're giving each one of them a unique ID. Okay, that's basically what an array is. So when we talk about an array in depth, we're gonna say something like, for instance, let's just show you the structure of an array. Okay, let's just say that I have an array called of names. So I have Ateeb, I have the names that are used up, Beharia, Caterpillar, destructive, sequence, fuck that, bro. Boop. There we go. Okay. So I have this array. If I wanna, and let's just say that this array is declared. So this is the first index. This is the second index. This is the third index. This is the fourth index. Okay. And let's say I want to access Beria, I would do, and let's just say this array is called like array. Okay. R. Okay. This is not how you actually initialize arrays. Don't initialize it like this. I'm just saying that this is the uh array name. So in order to access barrier, you would do something like R2. In order to access destructive sequence of nuclear codes for the United States of America, you would do R4, and so on. That's how you access an element. Now when you want to assign a value to an element in the array, you would do something like R at an index is value. Okay, so if I want to make like a fifth element, and I would do something like R fifth is equal to elephant. Okay, that is how you assign values. Okay. Uh, okay, perfect. All right. Also, we're gonna go over our lovely puppy slides after this as well, just as a quick recap. Uh, but yeah. So in order to declare arrays, we use something like declare array name, array one through, starting, ending of type. Okay, I'll explain this. So for instance, so I want an array 1 through 5 of integer. I would do something like declare array as array 1 through 5 of integer. This number over here is going to be the starting index of your array. So like for instance, in this array, the starting index is going to be 1. This number over here is going to be the length of the array. Now, another type of common question is to initialize all the values in an array to 0 or to something else. Okay, so you can do something like for I 1 to 5. Okay, because we want to access every element in the array. Next I, and then we're gonna do array at I is equal to whatever value we want to initialize it to. So for instance, I can initialize it to -1. Okay. Then yeah, I think that's basically it. You also have 2D arrays. The only difference between 1D and 2D array is that also when we do questions, I'll help you visualize 2D arrays better. But 2D arrays is basically like an array of an array which has a bunch of values in it. It's really simple. It's overcomplicated in classes. I'll explain it to you guys in a way that you can understand. And to declare 2D arrays, you do something like declare array starting ending of the first array, the outer array, this one, and then starting ending of the inner array. So if I wanted to declare this array right over here, I would do something like declare array. So the first one is obviously this starts at index 1 and it has how many elements? 1 element, 2 element, 3 elements. So it's going to be 1 3. And then the inner arrays, what do they have? They have 2 elements. So it's going to be 1 colon 2 of integer. Okay, that's how you declare a 2D array. Okay, and I think that's basically it. I can't think of anything else. Any questions from the syntax of pseudocode before we move on to the common algorithms given to us in the syllabus? Oh, one more thing. One more thing. Uh, Comments. I forgot comments. So whenever you want to write code that doesn't actually execute, or you want to like give remarks, you can do double slash, and you can write whatever you want. This is a comment. Okay, this is a comment. What else? I'm looking at Puppy's PPT right now and trying to find anything else that I missed. I think that's basically it. obviously you have your operators. Okay, yes, comments carry marks in the last 15 marker. You have your operators, you have plus, minus, slash, which is divide, multiply, raised to the power of, right? Where did I get what? And then of course you have the operators. You also have mod and div. Okay, so what mod and div do is that they're used in long division. Okay, again, we're gonna do this more when we get to the password questions. These are your operators, and what else do we have? We have our Boolean operators as well, uh, and or not, right? We have these, and I think that's basically all of pseudocode that we need to explain, the syntax that we need to explain, and then we're gonna move on to the pre-designed algorithms. Any questions? Any statement that you find confusing? Any specific syntax that you have problems with? Okay. Okay. Right. Round again. Okay. Yeah. Okay. So you have some library routines. Okay. You have some library routines. These are ucase, lcase. Okay. Ucase, lcase. Then you have length and substring. Okay. Actually, let me make a table out of these. Okay. Let me make a table out of these. Okay. So you have your routine. You have your syntax. You have your example, and then you have your example code, and then you have your output, example output. Okay, so the first thing that we have is lcase. Okay, so lcase basically returns all of the, so the syntax for this is gonna be lcase string. An example would be to take a string like ateeb, you do lcase ateeb, and this will return you this will return ateeb in all lowercase. Okay, like this, ateeb. Okay, then you have ucase, ucase string, again similar to that. Now if it's lowercase, then ucase of lowercase will return it to us in uppercase. Then you have length, which again similarly takes in the string, length string, oops, length string. So an example again would be ateeb. So length of ateeb would return 5. Then you have substring, which is used to get a specific part of the string. So it's gonna be, the syntax for substring is the string start length. Okay, so for instance, again, let's take ateeb for an example. Substring starting at ateeb, starting at 2 with length 3 would return t. Okay, this is what a substring would return. Then what do we have? We have instant origin. Okay, never mind. Yeah, so that's that. What do you mean population of? Okay, you mean like populating, initializing an array? Okay, I did that. I'll do that again, but no problem. Then you also have random. Okay, random returns a real from 0 through 1 inclusive. So you have random. So an example of this would be this, and it returns a real from 0 through 1 inclusive. And then you have round. You have round. Okay, and it takes in a real and it rounds it off to sorry, it takes in a value and the decimal points and it rounds it off to that many decimal points. Okay, So for instance, if you take in a value like 3.1415 and you do round 3.1415 to two decimal places, it's going to give you 3.14. Then you have in substring, won't we use something like that? Yeah, we would use something like that. Explain substring again. Okay, just a second. Right. Also, one more thing that you guys should know, how to generate random numbers. So in order to generate a random number, you would do this. Okay. So this would generate a random number from 0 through 6 inclusive. Okay. This is how you generate a whole number between 0 to 6. Okay. You should know this. Uh, Also, it's yeah, substrings. Okay. What is that asterisk for? This is for multiplication. This is for multiplication. Uh, I'm gonna give you a better syntax for the rounding. Hold on. Let me give you guys a better syntax for rounding. Okay. Yeah. We'll do substring just a second, just a second. Okay. Okay. So, all right. So the general formula is gonna be to do round. Okay. Is gonna be to do round, and then you do random multiplied by max minus min plus 1 plus min. I know this seems a bit tedious, but let me explain this. Okay. I know this seems a bit tedious, but let me explain this. So what does this statement over here do? Let me copy this. Okay. So that we know that we need a number between, let's just say, 2 and 8. Okay, we need a number between 2 and 8. We know that the maximum is what? 8, and we know that the minimum is what? 2. So if we plug that in here, we're gonna get random multiplied by max minus min is 6, 6 plus 1 is 7. So 7 plus 2. Okay, so this is a formula that you need to remember to generate random numbers. Okay, uh, and that's how we came up with this one as well. So when we needed 0 through 6, yeah, that's how we came up with this one as well. So when we needed 0 through 6, then we did 6 minus 0 plus 1, and we got that one. Okay, so this is a general formula that you need to remember to calculate freaking random integers. And about substring, so let's talk about substring in depth a bit. Let's say that we have this string over here. Okay, let me put in a string. Let me say inconspicuous. Let's make this a bit bigger. Okay, so we have this string. Okay, we have this string. Uh, Wait. I think my random has a problem right now. Wait. Six minus 0 plus 1 is 7. Hold on just a second. Yeah, you would do something like that if you want to generate between 1 and 6. I think that is it as well. I think I made an overly complicated formula. Uh, Wait just a second. Let me check something in the syllabus code. I think it's exclusive. I don't know if it's inclusive or exclusive, because if it's exclusive, then my formula is correct. Wait. Just a second, guys. Just a second. Where is the pseudocode guide? Random. I need to see if this random thing, if it's exclusive or inclusive. It doesn't say. Okay, I'm gonna assume that it's inclusive. Yeah, it is pretty weird. Just a second. Random multiplied by 6 if our maximum is 1, 1 times 6 is 6, and 6 plus 1 is... Okay, that is... No, I'm confused because the notes that I have open is something else. Wait, let me invite Puppy to the call. Let me invite Puppy to the call. One sec. Hey, Puppy. Acha, so the problem is that I looked at the thingy. So the thingy that you sent me, it says that this statement right over here is used to generate a random number from 0 through 6, inclusively, but I think this is incorrect because random gives us a float from 0 through 6 exclusively, right? It gives us a float from 0 through 6 exclusively. So the maximum value that you can get from random is 0.99999999999. Multiply that by 6, you get 6.9, sorry, you get, what am I even saying? I'm just saying k, if you have like something like 0.99999, oh my god, I'm being autistic right now. Hold on. I'm just confused on the random function. I need a general statement for the random function. I am, my brain is malfunctioning right now. Yeah, wait, hold on. How do I get you on the mic? How do I get you on? Yeah, I'll get 5.9999999. Yeah, exactly. 0.9999999 multiplied by 6 will give you 5.99999. You round that off to 0 decimal places, that will give you 5, because the round function, it drops the decimal. It doesn't round it off, right? Can somebody give Puppy a mic? Oh my god. Can someone give Puppy a mic, please? Hey,
Hello.
Puppy. Hey.
Hi. Okay. So, firstly, that example should be from the syllabus directly, so it shouldn't be wrong. I will send you in chat round and random as of it's defined in the syllabus. The random function returns a random number between 0 and 1 inclusive. So that could mean 1 multiplied by 6, and that would be 6.
Okay. Where's this from?
From the syllabus.
No, which document is this? I'm going blind, I'm going insane. The official syllabus has this?
Yeah.
I don't see this.
Search the word
Because
random.
someone sent a marking scheme as well. That
Yeah.
shows a different syntax right over here. Look, I
Can I
also
see?
attached this. Yeah. I
Oh,
just did a dot.
yeah.
That's crazy. Can you tell me which paper that's from so I can pull out? Oh, they did say October, November 2025. Oh, in 2025 we
What
2 3.
did the mark scheme ask for? A
Pulling it
random
up right
number
now.
between what? Yeah, thank you. Also, another thing, um, round just rounds to the near round of 0 decimal places rounds to the nearest whole number, not rounding down. So it rounds up or down.
It does round up or down. Okay.
Yeah,
I doesn't. I swear to God, I thought it dropped the integer, the decimal values.
that would be like type conversion in Java or C or whatever.
Because like the 9618 insert also says that it drops it. Why did I open up maths, bro? 0478. Wait. Stupid ass system can't even get their shit right. Holy God. Okay, can you see my screen? I'll pull up this MS, go over to the last part. Where is it?
Is the stream working for anyone? Because it's not working for me. Oh, give me 1 sec. Oh, wait.
No worries, no worries. This is the first time that I've had to pull off something like this. Holy shit. So right over here. So they said that 1 and 6 inclusive, right? They said 1 and 6 inclusive. And according to this, oh, where did he go? Oh. Guys, just give us like 5 minutes. Let us just sort this out. Uh, just give us like 5 minutes. If anybody's watching the recording, then just skip over this part. It's gonna be useless. I'm just trying to sort this out. Right.
Hey, hi.
The question
I'm
said,
so sorry. I can't see the
yeah,
stream. It just
you
keeps
still
spinning.
can't?
Do you mind sending? Yeah.
Yeah, of course. So they said that they need 1 and 6 inclusive, and they used this code over here to do that. So this
1 to
code over
6
here,
inclusive.
yeah.
They're wrong.
Oh God.
That's
So the
it.
mark
They're
is being
wrong. I'm
wrong.
sorry. Yeah. That's not the first time we've seen.
Yeah, that's what I'm saying. 0478 is the most stupid shit ever. Half of their questions are wrong. But basically, let me tell you what's happening. So the syllabus assumes that the 1 through 0 is what do you call it? It's exclusive, and then it rounds it off to the upper number, right? This one's assuming that, like normal convention, if you use random in almost all of them, random gives you 0 through 1 exclusive. So the maximum value it can give you is 0.999999. Multiply 0.99999 by 6, you get 5.99999. Round that off to drop the decimal, you get 5. And then you add 1 to get 6. That's what they're assuming, which is what's normally happening. So I don't know why the syllabus assumes that random gives you inclusive and it rounds it off to the nearest one. Because I swear to God, every single time that I've worked around with round, it's been dropping down. So what do you think we should go with?
Um, no, okay, wait. Um, I'm sorry, they're just stupid. It should be up or down.
I'm gonna take
I
pseudocode.
Yeah, pseudocode pro should prove my point.
God damn it. What the fuck is this? Uh, stupid shit ass thingy. Okay, guys, we're just gonna assume the example that's given in the syllabus that it's inclusive and it rounds up. Okay, okay. What the fuck, yeah. uh, yeah. Uh, I'm gonna email Cambridge after this for information on this. Because the syllabus doesn't say anything, so I don't know which syllabus that screenshot is from. Like I have the
The
syllabus open here, and
2026 to 2028 one.
yeah, I have it open here, and they don't even mention the. Okay, never mind. Okay, I see it. I see it. Guys, we're gonna go with the one
Also,
in the syllabus. We're just
I'll
gonna go with the one in
quickly
the
send a
yeah.
screenshot in chat where I tried it in pseudocode pro. Um, and yeah, you get a mix of zeros and ones, meaning it can round up or down.
Yeah. Okay, but we're just gonna go with the syllabus one stupid marking scheme. Okay, perfect.
Okay.
Thank you, puppy.
You have fun. I'll go down.
uh, you guys have probably witnessed the only time that I've had to assemble people to sort out this problem. Okay. Uh, right. So, guys, the thing is that okay. Right. So random, it returns a random real between 0 and 1 inclusive, and round, basically it rounds it up whether that's to the top or to the bottom. Okay, so if it's 0.999, it will round it up to 1, and if it's 0.1, for instance, it's going to round it down to 0. Okay, so in order to generate a random number, you would do something like this. Okay, you would do something like this. And in order to make a general syntax for this, it would become random random multiplied by max plus min. Okay, so for instance, if you wanted between 7 to 1 inclusive, you would do random. Wait, no, you would do max minus 1. You would do max minus 1. Puppy, I still need your help because I'm more used to the rounding decimal off thingy. You would do max minus 1, right? Yeah, you would do max minus 1. You would do max minus 1. No? No, because then if you want a number from 6 to 1, it would be random multiplied by 6, which would become 6, and then add 1 to it, then that's going to become 7. Like if you want from 6 to 1, then you would do random, which is like the highest value would be 1, 1 multiplied by 6, then plus 1, because 1 is the minimum. That would become 7. I think it's max minus 1. Uh, but it should be range generally. Okay. Fuck my life. Let's run iterations in pseudocode pros IDE. Let's run iterations in pseudocode pros IDE. I don't understand random either, honestly, at this point. But guys, again, if anybody's watching the recording, please just skip over this stupidity to. Yeah, this is peak humiliation. Yeah, come up, puppy, come back up to me, come back up to me, man.
Hello?
For x1 to 20, uh, declare max min integer
Yeah.
max
I was
7.
essentially saying max minus 1 in that case worked because your min was 1. But if, let's say, you wanted to start from 0, it would have been different. So basically, all you need is like the range, aka max minus min.
Max minus min. It would be max minus min plus
Yeah.
min. Is this the syntax, the one on
Yeah.
screen?
Yep.
Okay.
Well, I don't see anything on the screen. You're only sharing pseudocode.
I'll sign it in the chat. I'll sign it in this chat.
Yeah.
Perfect. This should not have taken this long, man. This should not have taken this long. Next X. I swear to God, I spent like $2 on getting pseudocode Pro, and then I lost the account. Oh, great. Oh, it's A level. Wait, IGCSE.
Oh, you can ask him. He gave mine for free.
No, I paid like $3 for it, and then I just lost the account after that. So we agree that this is totally valid, and yeah, we're just testing that out. What? Oh, oops. There we go. Cameron. Okay. Yeah, looks good to me. Perfect. And if I change this to 3, for instance. Okay, guys, we have reached a solution. Thank you, puppy. Thank
I
you.
gave a clean example in chat if it helps. But yeah, I'll go down now. Have fun.
Perfect. Thank you. Anyways, guys, this is gonna be our syntax to generate a random integer, okay? Um, all right, let's move on. As I was saying about substrings, round, what it does is literally round a number. 5.5 would round off to 6, 5.2 would round off to 5, and then random generates a random integer between 0 through 1. And if you want a random real from 0 through 1, and if you want a random fixed integer, then you would use this formula. Okay, and then obviously you would round this off to 0. You would do round, and you would round this off to 0, like this. Okay. Uh, Final unanimous freaking somebody can I think you should send this in the IGCSE channel as well, because I'm sure that people are gonna be confused over this. Uh but yes, guys, to generate a random number between a maximum and a minimum value, so for instance 7 to 2, you will use this formula. So if you want, you would let's say x is equal to a random number from 7 to 2, then you would do 7 minus 2 plus 2. This would obviously become 5. Okay. Oops, I added an extra comma. This is gonna come in your exam, bro. Random always comes, like literally always. But yeah, so this is how you generated the random number. Okay. Just remember this formula over here. Round is used to round off a real. So if you have like 5.5, round off a real to certain decimal place. So if you have 5.5 and you want to round it off to 2 decimal places, you would do round 5.5555. You would do it round off to 2, like that. Okay, and it would round it off to 2 decimal points. Yes, random is in 2210 and 0478 both. Okay, let's move on now. Substrings. Right, substrings. Let's say that the basic formula, the basic setup for substring is okay, substring, string, start, and length. Now let me make this just a bit bigger. Okay, there we go. Okay. All right. Okay, yeah. So each letter in a string is given 2 hours and 25 minutes only. It's been 2 hours and 25 minutes only. What? Oh, okay. So each letter in the string is given a value. Okay, so 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9, 10, 11, 12, 13. Okay, each letter in this value is gonna be given a freaking numerical value. Okay, now let's say that let's say I want the letters NSP. So what I would do is I would enter the string into the string part. So inconspicuous, inconspicuous. And since n starts at the 5th position, I would change start to 5. And since I want the 3 characters, so this is how many characters? 1, 2, 3, basic counting. So I would change length to 3, and this would give me NSP. Okay, if I wanted ICIOUS, if I wanted this part over here, I would change the start to the 8. UKI is at 8. And how many what is the length of the string? It's 1, 2, 3, 4, 5, 6. So it's gonna be 8 comma 6, and this is gonna give me IQS. Okay, and please look at Puppy's summary for round/random. Okay, that is how substring works. Any questions? Then we're gonna move on to procedures and file handling. Procedure functions and file handling. You use case when you want to compare one variable to multiple values, and you use if then else when you have multiple values that you want to compare with each other, if that makes sense. When you have more than one variable involved, or you want to use a logical operator like greater than equal to, less than equal to, greater than, less than, not equal to, etc. Okay. Uh, and okay, let's move on. Done, puppy. I'll stand. I'll be with you. I'll be with you. Do you also count spaces? What do you mean spaces? Also, guys, let's move on to functions and procedures. So the syntax for a function is function name parameter comma type returns type. Okay, and function. So for instance, if I want a function that returns my name, right? If I just want a function that returns my name and it takes in somebody else's name and it returns my name plus that name, so I could do something like function. Okay, and let's just say I want to call this my add name. Okay, so add name, and I can take in one name. So for instance, name one as string, and then I can take in another name two as string, and this is going to return string, right? So it returns string. Okay, and then I'm going to make a new string inside of here, and that's going to be name one and name two. We can add a space in between and name two, and then we can just return the string. Okay, that's how functions work. Functions must always return a value. Functions must always return a value. And procedures, on the other hand, don't have to return a value. They look like this: procedure, procedure name, uh, and then you can take in parameter and then type, and then just end procedure. So for instance, if I wanna print a Ateeb like X number of times, I could do something like procedure print a Ateeb, and I could take n as an integer, and I could do a for loop inside for x1 to n plus 1, and I could just print uh sorry output Ateeb next x and procedure. Okay. And then lastly you have file handling. Oh boy. Okay. I hope till this point everything's clear, and then we can move on to file handling. Where's my Discord? I don't understand functions. Functions are basically code inside of a snippet. So like for instance, this code right over here, we have this inside of this function. And basically functions return us a value, which we return through this point right over here. Okay. And we can take in parameters to calculate some value in the function, and then we can return it. This is the syntax for a function. So for instance, this is a function name. These are the parameters, and this is what it returns, what type it returns. And then here we calculate a string. So for instance, this was a function that concatenates two names together. So for instance, if I were to do add name Ateeb comma Sohail, this would return Ateeb Sohail, right? Could you explain how you added name one and name two? I concatenated. I just the ampersand is used to concatenate two strings together. Functions versus procedures? Simple. Functions are required to return a value. Procedures aren't required to return a value. I'm pretty sure there's like a 4 market question that also came on this, which we're probably gonna attempt through possibilities. Ampersand is not a thing, is it? Is ampersand in AS? Is it plus in pseudocode? I've done ampersand somewhere. There's nothing for pseudocode. Huh. You can't concatenate strings. What the fuck? What is this? Ah, string I mean, you can just use ampersand just as replacement, and they probably won't take marks off. Pseudocode Pro's IDE works with it. Pseudocode Pro's IDE works with ampersand. So, uh, yeah, just use ampersand, guys. Whenever you want to merge two strings, like for instance, if you have the string Ateeb and you have the string Suhail, and you want to merge these two, you could do an ampersand, which basically takes those two and just merges it. Oh, he did say that, but okay. Yeah, they probably won't take marks off. They probably won't take marks off. Uh, okay, what else do we have? We have file handling. Where is my... Okay, file handling, guys. File handling is, again, just like I said in AS, it's a really simple way of getting marks. Okay, it's not that complicated. Uh, Obviously, once you understand it. And honestly, it can't get that complicated in IGCSE anyway. So, okay, so basically, how file handling works, I'm not going to go that in detail, but you should just know the basics about it. Okay. Uh, Firstly, you need to know the file handling commands. Okay. There's a few file handling commands. Let me just boop, 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 boop. Okay. So there's a few file handling commands that you have. Okay. There's open file, file name, for mode. Okay. Then there's read file, file name, a variable. I'll tell you guys what this does. Then there's also write file, file name, var, and close file. File name. Okay, guys. Point number one. Point number one. Whenever you're dealing with files, always open and close them. Okay. Now, when we talk about modes in IGCSE, we have two modes. We have read or write. Read slash write. Okay. So, for instance, if I want to open a file for read, I would do something like open file text.txt for read, and then I would eventually close file text.txt. Okay. This is 1 mark. Again, any file handling question, you'll see that this is 1 mark. Okay, maybe 2 marks sometimes. Okay. This you have to do whenever you're dealing with files. Okay. Now, how does reading and writing work? When we have a file like this, let me make a file. Okay, let's say that it's a file with a bunch of names in it. Okay, John Smith, Rick, Adams. Okay, we have this file and it has 6 names in it. Okay, every time that you read, there's a pointer. Okay, there's a pointer like this that gets initialized. Okay, it starts at the top. Every time you read, it goes down. So when you open a file for the first time and you read, this value right over here, the first name, it's gonna get stored in the variable. So for instance, if let's just say that this is our file, okay, this is text.txt, and I run read file text.txt and I store this into a variable called v, and then I output v, it's gonna output a theme. And if I do this again, and then I output v, what's gonna happen now? It's gonna read file one time and it's gonna read the first statement, it's gonna store that in v. Then it's gonna read file again. This time the pointer will go down, and instead of saving a theme in v, it's gonna save Suhail in v. Okay, so now Suhail is gonna get output. Okay, and if I do this again, if I do read file one more time, oops, if I do read file one more time, then the pointer is gonna go down again. Again, this time it's gonna output John, and then I do it again and it's gonna output Smith, and so on and so forth. Okay, that's how read file works. Uh then similarly you have write file, which basically writes. There's literally not much that there is about that. It writes the line at the end, I believe in IGCSE, it just writes it at the end. So the example for that code would be open file for write, and let's declare v as like v is CS's pog, and you could do write file text.txt v. That is how write file works. Any questions from pseudocode so far? This is yes, file name with quotation marks. Any questions from pseudocode before we move on to the preset cases? Okay. Ah, God, I fucking hate IGCSE pseudocode. It's the most useless shit ever. Let's go all the way to chapter 7. And we have linear search, bubble sort, totaling, counting, finding maximum. Okay. Okay, for these ones, I'm gonna refer to my old notes side by side so that I don't miss anything, because I'm pretty sure that I covered basically everything in here. So don't mind me continuously shifting back and forth. Okay. So let's start off with this was me explaining what I just did, all of that. Okay, let's start with counting, totaling, etc. Okay, let's say that we want to take in no double quotations, use double quotations. Marking scheme is wrong. The marking scheme is wrong, use double quotations. Literally stupid ass. They don't even know how to solve their own papers, and then they cut our marks. Like, bruh. I would take out the rage that I still have from my PD2, but I already took that out in the AS session, so I'm not gonna burden you guys with that. But yeah. Anyways, what was I saying? Yes, totaling. Let's say that we want to take in an input of take in 100 values and add them all and calculate the total. Okay. First off, how do we take in 100 values at all? Okay. How do we take in 100 values at all? We run a for loop. For x 1 to oops, let me just okay. For x 1 to 100 input value. Next x. This is how we take in 100 values. Okay. This is how we take in 100 values. Now, if I want to take the total, what I will do is I will initialize a total variable at the start, and every time a value is inserted, I'm just gonna add that value to the total like this. Okay. Output total, and then I can output total at the end. Pretty simple. Any questions? Yeah. You can also do something like okay, let's talk about counting then. Okay, yeah, let's talk about counting then. Now, if I want to take in, for instance, let's just say that I wanna input. Let's say I also want. Let's just edit this exact question. Okay, let's say that and count the number of numbers of values that were greater than 69. Okay, then what I will do is that every time a value is inputted, I would do a check. If value is greater than 69, then count is equal to count plus 1. End if. I'm also gonna add a count variable at the start because we have to initialize that variable as well. Don't forget to initialize and declare, guys. And yeah, and then at the end I can also output count. Okay, and yeah, so that's counting. And then you have minimum, maximum, and average. Okay. Minimum, maximum, average. Okay. So there's two ways to do this. First way is if you know the range. The second way is if you don't know the range. If you know the range of the numbers, okay, so you know that they're either less than something or they're greater than something, then it's pretty simple. You're gonna make a max value and you're gonna make a minimum value and you're gonna make a sum value. Okay. If you know the range, okay, so let's just say that the smallest number possible is 0, so you're going to set maximum to that. And if you know that the biggest number possible is 100, then you're going to set the minimum to that. Sometimes you can get away by putting, if you don't know the range, sometimes you can get away by putting minimum as this and maximum as this, but I don't recommend this. What I do recommend, however, is doing something like this. You set all of these to 0, okay? This is in case you don't know the range, okay? And then what you're going to do is you're going to repeat. Okay, let's just say that I want to take in numbers until number is -1 and output max, min, average. Okay, let's say I want to take in numbers until the number is -1 and I want to output the maximum, minimum, and average at the end. So what I'm going to do is that I'm going to input a value, okay, and until value is -1. Okay, I'm gonna input the value, and if it's the first value, okay, then I'm just gonna set all of these to it. So we're gonna input a value outside as well. Okay, input value. Just a second. We're gonna input a value, and we're just gonna set maximum, minimum, and sum to this value. So max is value, min is value, and sum is value. You honestly don't have to initialize these either, so you could just get rid of these. But we're basically assuming that the first value is gonna be these. Okay, we're assuming two things here. We're assuming that the first value is gonna be this, and we're gonna assume that a value is entered, more than one value is entered. Okay, then what we're gonna do is we're gonna check if max is less than value. Okay, obviously if maximum is less than value, what is maximum? It's supposed to be the largest number. So if maximum is less than this value, then obviously this value should be the maximum, right? So value L, and if min is greater than the value, right? So that means that the value is less than minimum. So then minimum is gonna be the value, and if. And obviously at the end, we're just gonna add sum to the sum plus value. And then what we're going to do is at the end of the loop, we're going to output max, output min, and to calculate average, we're just going to do sum divided by however many numbers were entered. So we don't know how many numbers were entered. So we're going to take in, what do you say? We're going to take in account variable as well, and we're going to initialize this to 0. Also, it's better to use a while loop here, while value is not equal to -1. Okay, and while. It's better to use a while loop over here. Okay, I did it wrong. What did I do wrong? Count is equal to count plus 1. And then average is just going to be sum over count. What did I do wrong? It should be value greater than or less than min max. It doesn't matter. It doesn't matter. Because it doesn't matter. Look, because if your value of maximum is, let's just say that you input the value what? You input the value 5. So this is 5. Oops, why am I using? Okay, so you input the value 5, and this is 5. This is 5. This is 5. And let's say you input 5 again, and this is greater than, less than, or equal to. Okay, then it's just gonna change the values to the same thing. It's just gonna change the values to the same thing. The max is just gonna become 5 again, and the minimum is just gonna become 5 again. Or if you input something else, okay, if you input 7, and then what's gonna happen is that 7 is minimum. Wait. Yeah, so 7 maximum is gonna become 7, and then this is gonna become 5, and then you're gonna input 7 again, and it's just gonna change this back to 7. It doesn't matter. You can change it to greater than or equal to, but it doesn't matter. Not in this case. Look. I'll explain it to you. Let's say that you input the value 5. Okay, you input the value 5. That means that max, min, and sum, all of these are 5. Understood? All of these are turned to 5, right? All of these are turned to 5. Now, when you use less than or equal to, what's gonna happen is, and you input 5 again. Let's say you input 5 again. If you use less than or equal to, this will get executed. But what will happen? Maximum is already 5, right? What's it gonna do? It's just gonna change it to 5 again. Did that change anything? It's still 5. Right? It's still 5. It didn't change anything. It didn't change the value. It's just 5 again. Do you see that? It doesn't matter. You can do it. What if we have multiple number of values? Okay, let's just assume that it's 8 and it's 3. Okay, and we input the number 10. Or we input the number 8. But if max is also equal to the value, won't it be 5 is less than 5? Yeah, exactly. It's just going to skip over the statement. It's just going to skip over the statement. Maximum will still remain 5 now. Yeah, maximum will still remain 5. It's just going to remain 5. It's not going to change. It's just going to skip over it. If it's the same values, then it's just going to skip over it. But if it's not the same value, it's going to change. It doesn't matter. You can use equal to, you can use equal to, you cannot use equal to. Can you try with value less than min max? Okay, let's try with 0. What's going to happen? It's going to see that, oh, 0 is that minimum is greater than 0, so it's going to set 0 as minimum. This would have happened if it were equal to or not equal to. Okay, it would have happened either way. It doesn't matter. Also, yeah, so you calculate the average by sum divided by count. And one more thing is that sometimes this also passes that you can use like an upper value of 1 gazillion, a really large number, and a lower value of negative 1 gazillion. But you should not. You should do the thing that I just told you, which I just explained to you guys. Input a number, set the values as that, and then do it that way. This is the most efficient way. You only set them when you know the range. You only set them when you know the range. Okay. Then we have okay, what else do we have? Flag looping. Okay. This is not a concept that is in the syllabus, but it's a helpful concept to know anyway. We use flag looping whenever we are confused. Whenever you're confused with something, use flag looping. Literally. Flag looping is a solution to all problems. It's the holy grail to all problems. Okay? It's the holy grail to all problems. Step. Step is in AS syllabus, no? Step is in AS syllabus, it's not in IGCSE syllabus. But yeah, flag looping is the holy grail to all problems. Okay, how does it work? You make a flag, you initialize it to something, and you say while not flag, do something. Literally, that's it. That's basically what flag looping is. You set a flag, and until that flag is proven false, you continuously loop. You continuously run iterations. That's what flag looping is. Until a flag is proven false, you run it, run the whatever is inside of it. That's what flag looping is. And you can make a condition. You can say something like, "Oh, run a loop until the value is greater than 10." You can input value, and if value is greater than 10, flag becomes true, and this will hence break the loop. This is what flag looping is basically. You initialize a flag, and then you let a loop run until the flag is proven to be the opposite thing, and then yeah, not flag is just flag equal to true. Yeah, not flag is the same thing as flag is not equal to true. Yeah, exactly. Not flag is just the same thing as this is the same thing as if you did flag is not equal to true. This is the exact same thing. Same thing. Potato, potato. Why and when do we use flag looping? Whenever you want to loop, honestly, whenever you want to loop and there is a condition that has to be fulfilled for the loop to terminate. Okay, so whenever you want to loop and there is a specific condition that will cause the loop to terminate. So like for instance, you want to keep on looping until a negative number is input. So you're going to keep on looping, you're going to initialize a flag and you're going to make it loop over and over and over again until a negative number is input. When a negative number is input, then you're going to change the value of the flag and the loop will stop. Just like how we did here. As soon as a value greater than 10 is input, the flag will change, will become true, and the loop will break. That's why flag looping is used. Can't we do this with? Yes, you can. Absolutely, absolutely. You can do it with repeat until as well. You can do flag is equal to false. You can do repeat input value if value is greater than 10, then flag is equal to true. And if, right, until flag. You can do this repeat until it'll be like this. This is the same thing as flag is equal to true, by the way. This is what flag looping is. Step is not in your syllabus, but step basically means that instead of iterating by one, it just iterates like two. Does something like this work? For negative number, repeatedly input until a negative number. Yeah, that works as well. We're gonna talk about that in validation in just a second. We're gonna talk about this in validation in just a second. After we're done with linear and bubble sort. Okay. Let's talk about bubble sort. Oh boy. Okay. I'm gonna copy this. I'm gonna paste it next to us, just so I can have an idea of what I'm explaining side by side. Okay. Ignore the code. Okay. So let's say that you have an array like this. Okay, you have an array like this: 65, 32, 12, -2, 56, 100, 102. And we want to sort this in ascending order. Okay, you have an, I guess that works. Yeah, the swap is like flag looping. I'm doing this through flag looping. If you wanna learn the code that was just sent in chat, you can learn that, I guess. Or you can do this one. This one is a bit more longer, but it's easier to know. But they're the same thing actually. They're basically the same thing. Yeah, this is literally the same thing. Okay. So bubble sort basically means that, look at the visual representation of bubble sort. Look, let's just take an array. Let's just take a small array, okay? 5, 3, 6, 2. Let's just take this array for now, okay? Let's say that I want a bubble sort on this. The way bubble sort works is that we have this pointer over here, and it starts at the start, okay? It starts at the very beginning. It checks to see if this value is greater than this. If it is, then it puts this value in a temporary box, okay? It puts it in a temporary box, okay? A temporary variable. It brings this value over to the first position, and then it brings this out of temporary and back over here, okay? And then it moves the pointer, and then it checks, is this value less than this value? If it is, then it's just gonna move on. Is this value less than this value? It isn't, so it's gonna put this into here, it's gonna bring this over here, and it's gonna bring this over here, and it's gonna move on. It's gonna go to the start now. It's gonna go to the start now. Is this value less than this? It is. Sorry, it is. Yeah, so it's just gonna move on. How do I, bruh, annoying it. I'll just use a line. So now it's gonna move on here. Is this value less than 2? Is 5 less than 2? It is. So it's gonna put, bruh, let me make a better 5. Let me make a better 5. 5, okay. So what it's gonna do is it's gonna put 5 in a temporary variable. It's gonna bring 2 over here. So it's gonna bring 2 over here, and it's gonna bring 5 back here. Then it's gonna move on. Is 5 less than 6? Yes, it is. So it's gonna go back. Is 3 less than 2? It is. So 3 idhar gaya. 2 comes over here, 3 comes over here, and now the loop is sorted. Understood? This is how a bubble sort works. Okay, this is how a bubble sort works. Probably 2 more hours. Okay, so this is how bubble sort works. Now, in order to make the implementation of this, what we're gonna do is we're gonna work with a few things. We're gonna work with the start and end variable. Okay, start and end variables. What is this? Start is the first index, and end is the final index. Okay, so in our case, it's gonna be 1, 2, 3, 4, 5, 6, 7. Okay, this is the final index or the length. Okay, all right. So what we're gonna do is we're gonna do a repeat loop, repeat until. Okay, we're gonna initialize a flag, okay, as true. We're gonna assume that the array is sorted. We're just gonna assume that the array is sorted, okay? And we're gonna prove ourselves wrong. That's what we're gonna do. We're gonna prove ourselves wrong. So how are we gonna do that? We're gonna do this. We're gonna make a pointer go through every position, okay? We're gonna start off for index, which is gonna be the starting value, to ending value -1. Why did we do -1? Because look, if let's just say that our value reaches, for the for loop, what's it going to do? It's going to start at 1, 2, 3. Let's say we didn't do -1. It's going to reach 4. But then it's going to compare the next variable, which doesn't exist. There is no variable after this. Look at the code. What's happening is that it's doing index plus 1. If it reaches the last index, which is 4, then it's not going to be able to compare it to anything. So that's why we do -1. Okay, that's why we do -1. Okay, then what we're going to do is we're going to add value 1 as values index. You don't have to do this. I'm just doing this for simplicity. And then you can do values index plus 1. What did we do now? We basically made two containers, or we just defined this thing over here. We just defined this as value 1. We just defined this as value 1, and we decided this as value 2. Also, I'm going to move these around a bit so that I can explain this better again. Sure, this works. Okay. So what are we going to do next? What did I tell you guys? We're going to compare this one with this one. So we're going to see if value 2 is less than value 1. So what will happen? Sorry, I think I'm gonna, oh my bad, I'm gonna just make these two. Okay, if value 2 is less than value 1, what's gonna happen? We're gonna swap these, right? We're gonna place one of these into the temp box. We're gonna bring this one over here, and then we're gonna bring it out of the temp box. Okay, we're gonna bring it out of the temp box. Okay, so let's say this is our array, this is our original one. Okay, this is our original array. Is value 2 less than value 1? It is. So we're gonna swap them. What are we gonna do? We're gonna make a temporary variable, okay, which is our box. We're gonna make a temporary variable, and we're gonna set it as value 1. What happened? Our value 1 went over here. Now we're gonna make value 1 equal to value 2. How will we do that? We're just gonna say that values at index become value 1. Okay. And what are we gonna do next? We're gonna bring this out of temp back to here. So we're gonna say values at index plus 1 is equal to value 2. Sorry, is equal to temp. Okay, and then we proved that the loop isn't sorted, so we're gonna do flag equal to false, and then we're gonna do end if, and we're gonna do next index, and then we're gonna do last is equal to last minus 1. Why did we do this? Because eventually what's gonna happen is that it's gonna bring this over to here, and we know that the largest possible is already gonna be at the end. So we're just gonna make our last less than that. Okay, we're just gonna make our last less than that. Okay, so it stops at here, so that it's more efficient. Okay, now instead of using value 1 and value 2, I would suggest that you guys just directly use the values index. So you would do something like index plus 1, sorry, index, and then you would do values index plus 1, and then you would do temp. I would suggest that you guys do it this way. Okay, and yeah, this is the most efficient bubble sort algorithm that you're gonna get. I hope it's understandable. If there's any confusion, let me know right now. Bubble sort. Any confusions at all? Bubble sort. Why do we need to prove ourselves wrong with flag equal to true and not flag equal to false when flag is equal to true at the end? Because look, flag in our case, oh shit. Oh, rest in peace, my phone. Okay. In our case, flag is just us saying that it's sorted. Okay, you can change this to sorted. Okay, this maybe it explains to you better. We're just assuming that the loop is sorted, that the array is sorted, and every time that we find an inconsistency, every time we see that, oh, it's not sorted, then what we do is we make sorted false so that it runs again. And then obviously we're gonna do until flag or last is equal to 1. Okay, so as soon as we know, look, now what's gonna happen is that, look, now what's gonna happen is that if the loop is sorted, then this piece of code will never run, right? This piece of code will never run. So that means that the sorted will remain true and the loop will exit. How does it work for strings? The exact same way. the exact same way. And if you want to change this right now, what is this? This is in ascending order. If you want to change this to descending order, you'll change it to greater than. Simple. What part don't you get about bubble sort? What part don't you get? The flags part of it. Okay. Basically, what we're doing is that we're just gonna assume that the loop is sorted. Okay. Sorry, that the array is sorted. We're just gonna assume that the array is sorted at the start. That's what we're doing. That's what the flag is, right? The flag just signifies if it's sorted or not. Okay, we're just assuming that it's sorted. And then what we do is that we do our bubble sort thing. Okay, we go through the array. We go through the array. We point our pointer through the array. We go through the first, second, third, and fourth. We keep going through there until an inconsistency is found. Until, like, for instance, this one, this area right over here, this isn't sorted. What's gonna happen is that it's gonna say that it isn't sorted. Okay, hence it's gonna run again, and it's gonna keep on doing this. It's gonna keep on doing this until there are no inconsistencies. When it's fully sorted, okay, when it's fully sorted like this, what's gonna happen is that sorted is gonna become true, right? It's gonna become true because the loop sorted, and then there will be nothing. There will be nothing that's gonna happen to make it false, and hence the loop will exit. Is there any low difficulty 15 markers? Just take any 15 marker from, just take any question from AS level. You should be able to do it mostly. AS level pseudocode is just IGCSE pseudocode. I did my AS exams, I did my CS AS exams without any prep, solely relying on my IGCSE knowledge. And I still managed to score really high. So it's basically IGCSE CS. The theory is different, pseudocode is basically the same. Why isn't it values index -1? Because we're comparing the current value with the next value. We're not comparing it with the previous value. We're comparing it with the next value. We're going left to right. Okay. My guy, this is not A level P. This is not CS A levels. This is IGCSE A levels. We're not doing P3. This is P1, P2, and this was P2 speedrun. This is IGCSE CS, not A level CS. Yeah, easy peasy. All right. Then we have, what do we have? We have linear check. Okay, we have linear search. We're gonna linear search, and then we're gonna take like a 5-minute break. Okay. So let's say that I have an array. Let's say I have this array. I wanna figure out a value in it. So what I'm gonna do is I'm gonna loop through each array, and I'm gonna basically see if the value at each index is equal to my value. Pretty simple. So what I'm gonna do is that I have an array. Okay, let's just call it array. Let's just say I have an array that is like this. Okay, 1, 2, 3, 4, 5, 6, 7. Or let's make it better. Okay, let's make it better. Let's make it random. 90, 80, 30, 45, 33, 69, 74, 67. Okay, let's say that I wanna loop through this array, and I wanna, what do you say, figuring out where the value 30 is. So what I'm gonna do is I'm gonna take an input search, okay, and I'm gonna initialize the search and index variable to -1. Okay, let's just say we haven't found it yet. Okay, we haven't found it yet. What I'm gonna do is I'm gonna do for I is equal to 1 to length of array, length array. Okay, and I'm gonna compare each element at each index in the array to the value. Okay, and if it's true, then I'm gonna make the index that. So what do I mean? If array at I is equal to index, is equal to search, then index is gonna become I, end if, next I. Okay, and if index is equal to -1, then obviously it was not found. Then output not found, else output found. Got it? Pretty simple. Pretty simple, pretty easy peasy. What is meant by I? That's just a variable we're using to loop. Are we speed running or slow running? I think covering 3 years worth of syllabus in what, 6 hours is pretty speed run to me. Pretty speed run to me. That's linear search. I is not the same thing as index. I'm just gonna change the naming. I'm just gonna change this to found index, so that's a bit clearer for us. Okay, there we go. You can also just output found index. Found index is basically the index at which the variable was found. So what's gonna happen is that if I'm searching for, like let's just take this array for instance. If I'm searching for the value 5, what's going to happen is that it's going to go through each one, and when it finds 5 at which index, this is the third index, so it's going to store this in the found index. It's going to store 3 in the found index, and it's going to output that at the end. Any questions? Let me see anything else that we have. Okay. Now we're gonna move on to a bit of theory part, and then we're gonna move on to past papers because we're basically done, I believe. Oh no, validation. Validation. Completely forgot. Yep. Yep. Okay. So we need to do validation. Okay. Uh so validation, where is it? Okay. So there's a bunch of validation checks. I'll just copy paste this entire section because and I'll explain it because it's pretty repetitive in that case. So look over here. What is validation? First of all, they can ask you for the difference between validation and verification. Validation means to check the reasonableness of a data to see if data is reasonable. I'll change the definition. Check if data is check if data is reasonable before it is accepted into the program. Obviously, learn the marking scheme definitions. Please use pup notes. I'm gonna send that in the chat. Please use pup notes. They have actual marking scheme definitions that are gonna get you those marks. They have keywords. Don't use these notes to memorize. But anyways, there's a bunch of checks. Okay, so there is a range check, there's length check, there's type check, there's present checks, there's format checks, and there's check teacher. Okay, let's start off with range check. Okay, let's start off with range check. Now, it's pretty simple. I'll remove the pseudocode. It's pretty simple. We want to input a value. Let's define a question. Validate a value for it being between 1 and 100 inclusive. When we're talking about validation, it's best to use repeat until loop. So we're going to say repeat. We're going to say repeat input value until the condition is met. Until what do you say? Until value is greater than or equal to 1 and value is less than equal to 100. Value is less than equal to 100. Okay, pretty simple. You can also output an error code if it's not. So you can say something like if value is less than 1 or value is greater than 100, then output error. Okay, pretty simple. Okay, then you have length check. Let's say that I want to input a string. Let's define the question. Input validate for a string to be between 4 and 8 characters, inclusive. Pretty simple. We're gonna make another repeat. Input value until length of value is greater than or equal to 4 and length of value is less than or equal to 8. And then again, you can add the message if length value less than 4, less than 4 or length value greater than 8, then output length must be between 4 and 8 inclusive. End it. Pretty simple. Can't you do linear search with flag? Yes, you can do linear search with flag as well. You can do linear search with flag as well. The reason I did it with an index is because sometimes they may ask you to, what do you say? They may ask you to give the index at which it is found. Okay, they may ask you to give the index at which it is found. For that case, you're going to store the index. Yes, you can do it by the flag looping as well. You can do it by flag looping as well. But it's the same thing. It's the same thing. Okay, I'm just storing index. You can do true, false. You can do it using flags. It's up to you. But I think using an index is better because just in case they ask you to tell the index as well, then you can just do output found index. Just like that. They can sometimes ask you to just give the index. Okay, so you can do it through index or you could do it through flag looping. It's completely up to you. Completely up to you. Then you have type check. So the only reasonable thing that has ever come from type check is Okay, I did not explain div or mod to you guys. Let me explain div or mod. You have a long division. 7, 2. Divide this. You're gonna get 6, 3, minus 1. You're gonna get 1. If you did 7 mod 2 and 7 div 2, what would be the difference? Can anybody tell me the answer to this? I don't think I did 7 div 2 and 7 mod 2. Mod is the remainder while div is the quotient. Exactly. So this thing over here, this is going to output the quotient, which is 3. Okay. One more thing, it's going to be, I'll explain it to you guys in a second. There has been a syllabus change, which I'll explain to you guys in a second. But yeah, so when you do this, div is going to return you guys 3 and mod is going to return you guys 1. Mod is going to be the remainder, div is going to be the quotient. Okay, pretty simple. And the way that this works, previously you did, yeah. Okay, so the way that this will work is that, boop, 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 boop. Let me just confirm this through the syllabus because I'm pretty sure this was edited. Pretty sure. Let me just boop, 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 boop. Yeah, never mind, never mind. Okay, so for instance, and look, if I want to make sure that a number is an integer, a type check, if I want to make sure that a number is integer, what will I do? I'll divide it by 1, obviously. So if I divide it by 1, what am I going to get? 0. But if it was a decimal and I did this, 7.1, if I divided by 1, then what would I get? I would get 0.01 as the remainder, right? So in order to make sure that a number is freaking integer, what I can do is I can make a repeat input value until div of, basically we need the remainder, right? Sorry, mod was a mod or div? Right. So just a second. Right. Okay. So as I was saying, until mod of value, comma 1, oops, is equal to 0. Okay. If mod of value comma 1 is not equal to 0, then output value must be a whole number. And if. Okay. I think my old notes were wrong because what I did in my old notes was something else, which I have no clue what the hell I did. But I have no clue, but I think it was mod and I used div, so that is a problem. I have no clue what I'm doing over here because I didn't mention it either. But yeah, use mod if you want to make sure that it's an integer, guys. Use mod if you want to make sure that it's an integer. And then oh yes, Elysian are really good. Elysian notes I've heard are really good. I would suggest that somebody send Elysian notes in chat for P2. I've heard that they're basically marking scheme based. So yeah. Then you have presence check, pretty simple. Pretty easy. You're gonna do repeat input value if value is not sorry, until value is not equal to a space. If value equal to space, then output value must be existent. And if. Then you have format check. The most common way a format check is through this is only P1. Elysian are only P1. Oh, okay. Then just use pub notes. Just use pub notes. Then just use pub notes, yeah. Okay. How do people end up making whole ass video games from that pseudocode? I could know. Uh, Oh god, it's really fun and easy. Pseudocode Pro, when he was making his IDE, he asked me if he should include HTML in pseudocode just as a funsies, and he ended up implementing HTML in his pseudocode, and me and Puppy ended up making a website out of it. Well, Puppy made a website out of it. I ended up, just messing around and trolling people through pseudocode. It was really fun. It was really fun. All right. Anyways, now you have a format check. Format check is pretty simple. Okay, let's say that you have a string that is that always has the right four as ABCD. Pretty simple. You're gonna use substring. Okay, so for instance, if you have a format that says that last four characters will always be ABCD, what you're gonna do is you're gonna repeat input the value input string. Okay, and in this case we're gonna use substring. Okay, now what we're gonna do is that we're gonna enter the string, we're gonna start at position 5 and we're gonna take it for 4 is equal to ABCD. Okay, we're just gonna make sure that the last four are always this. Okay, and then you can do if substring string 5 4 is not equal to ABCD, then what do you call it? Output last four characters must be ABCD. It can also come in the form of a length check or what else. Okay. Now, one thing that you guys have to know is that some teachers say that left and right are part of your IGCSE syllabus. They are not. They are not. You cannot use left, right, or mid in your syllabus. You must use substring. Left, right, and mid are not part of your syllabus at all. You must use substring. Left, right, and mid are not part of your syllabus. You must use substring. Uh, what else do we have? Then you have a check digit, which is basically the final digit that's calculated using a calculation algorithm. The way you would do this would be to take the last digit. So for instance, let's just say that our check digit must be like 5. So you would do something like repeat input string until string at substring string at I'm gonna write this down here. Check digit must be 5 example. Okay. So let's just say your check digit must be 5. I feel like check digit might come in your guys' exam tomorrow. It's who knows. But basically, check digit is to compare the last digit, right? So until string at the last digit, so length of string minus 1, comma 1 is equal to 5. Okay, this is a pretty simple example. Okay, what are we doing here? We're repeatedly inputting string until, like for instance, if this is our string, we're repeatedly inputting it until oops, this won't be minus 1, this will just be length. My bad. Until the last digit is 5. Pretty simple. Then you have verification, which is making sure data is copied correctly from one place to another. And data is basically verified at the time of entry. You should know this definition. You have double entry check, which is basically to input data twice. They can ask you for pseudocode of this, in which case you just do input value, and then you check. So for instance, you could do something like repeat output enter value 1, input value 1, output enter value again, right? Input value 2 until value 1 is equal to value 2. Pretty simple. Okay, and then you have screen and visual check, which is basically that the user checks the screen manually. And with that, oh yes, okay, then you have some more theory that you need to know. First off, you have so chapter 8. Honestly, I might just not write this because this is basically theory. Let me just copy this and remove the things that we have already done. Okay, let me just control C. Chapter 8 programming. Okay, all right. So You have programming constructs, which is data use, sequence, selection, iteration operators. You should memorize these by heart. Can we go through double entry check? What do you mean double entry verification? Can you like write me a proper question? I don't understand what you mean by double entry verification in pseudocode for an array. Okay. Then you have input and output. File handling we've already done, so I'm just gonna remove this. Actually, I'll keep the definition that computer stores data in a file. Pretty simple. Okay. So what are library routines? They're basically pre-tested and available for use. A standard library of functions and procedures. You should know these definitions by heart. We'll get a break as soon as we're done. This is like 5 more minutes. What are scopes? I'll tell you in a second, just a sec. Then creating a maintainable program. They can often ask you questions like how can you make a maintainable program, or how can you help other programmers understand your code better, which you will answer meaningful identifier names, divide each module into procedures and functions, comments. Okay, comments on your code. Then there's string handling, which we have also done. Arithmetic operators, I'll just leave this here. Nested statement basically means to place a statement inside of a statement. So for instance, if you have an if statement which has an if statement inside of it. So for instance, you have something like if condition, and then you have another if statement inside of it. This is called a nested if, hence the word nested, because it's nested inside of another thing. Then again, we already discussed procedures and functions, so I'll just leave the definitions over here. Procedure is programming statement without any return value, and is a collection of programming statements with a return value. Somebody asked me about scopes. Scope is basically local and global variables. So when you talk about a local variable, if you have a function, okay, if you have a function and there is a variable called x which is defined inside of that function, this is what we call a local variable. But if you have a function that is, let's just say like this, if you have a function but the variable is defined outside of that function and it can be used anywhere in the program, then we call it a global variable. Then there is also a syntax that I mentioned here, which I'm not sure is accurate according to this new syllabus. Let me just check. Global. Yeah, so there is no such thing as declaring it as global. It's just going to be that. Okay. A local variable can only be used within the scope that it's declared in. That's what I mean. For instance, if you have a function and you can use x is equal to 6, then the scope of this function is just whatever lines inside of it. So if you run output x outside of the function, so like let's just say that the function it ends over here, and you run output x, it will produce an error because the variable x was inside of the function scope. That is what scope is. And then you have arrays, which again, I think I'll leave this here, but I already explained all of this actually in chapter 6. Sorry, chapter 7. And then filling up array, pretty simple. Populating an array, somebody asked about this as well, which I already did, but I'll do it again. You declare the array. If it's a 1D array, you just do 1 to length of the array, okay? So you just start from 1 and you go till the length of the array and you populate it with whatever you want to do it. So you can populate it with 0, you can populate it with an empty string, whatever you want to do. Then you have 2D arrays. It's a similar thing, but this time you use 2 for loops, so row and column. So the first one starts with the first, and then the second one starts with the second, and then you do this. Pretty simple on how to populate the array. Then that is basically it. Make sure that you have these memorized. Somebody, you can take a screenshot. I'm pretty sure these definitions should be okay. Make sure that you have these memorized. These are really common questions that will come on your paper tomorrow, most likely. This is a really common question about programming constructs, and this is a really common question as well. It can probably come. Then somebody asked a question. Input 10 numbers and store them in an array. Okay. Let's do this one and then we'll take a break. The question they asked is this. Input 10 numbers and store them in an array. Input 10 numbers again, and as each number is input, compare it with its corresponding number in the array. If the number match, move on to the next number. If they don't match, ask for the number to be re-entered. Pretty simple. Okay. So what we're going to do is we're going to first input 10 numbers and store it in an array. Okay. For x is equal to 1 to 10, and we're going to store it in the array. Okay. We're going to input a value, input num, we're gonna do array at x is equal to num, and that way we have an array. This is also what it's called populating an array. Okay, this is also what it's called populating an array. So this is what we did first. Now what we're gonna do is we're gonna do input. We're gonna input it again. Okay, so for x is 1 to 10, we're gonna input num again. Now we're gonna check if num is equal to the original number. If array at x is equal to num, is not equal to num, okay? If is not equal to num. If it's not equal to num, then we ask for it to be re-entered. Okay, we say output enter number again. And then we take in number 2 and we store the array at x as number 2. Because they said if the store the re-entered number in the corresponding array location and move on. Okay, and then we're gonna do end if x. And when all the numbers have been checked, output checked, completed. Pretty simple. Hopefully you understand. Oh, my bad. I said come in your exam. My bad. Hopefully you understand this. We've been grinding for what, like 6 hours now? We started at 5:30 and it is currently 10, so it's been 4.5 hours. Alright, that is basically the entire syllabus completed. 4.5 hours, a little bit more than I anticipated, 30 minutes more than I anticipated. I think I said 3 to 4 hours, 4.5 hours. Now we're gonna take a 10-minute break and then we're gonna actually let's change that to a 15-minute break. We'll be back at 10:15 to do past papers. I'll give 15 marker tips at the very end. We're gonna do past papers. See you guys in 15 minutes. We're gonna start at 10:15. Also, if you want to leave, you can, because we're gonna do like 3 past papers. All 3 are gonna be uploaded on YouTube at the end anyway. So if you want to go to sleep, you can, and you can watch the recording in the morning. Okay. If you want to go to sleep, go to sleep. Get rested. Don't sacrifice your rest over this. You can watch the recording in the morning. The most important thing that I would say that you shouldn't watch in recording is the syllabus part, which we just finished. So, because you can have questions during the syllabus, but past papers are pretty self-explanatory. This will probably be the last class I give on IGCSE Computer Science. Uh, it's been a wonderful journey for the last 2 years. May, June 2024, October, November 2024, May, June 2025, October, November 2025, May, June 2026. Every single session, continuous complete syllabus completions. The reason I kept doing this over and over again was because we could never properly get a recording, and we could literally every time somebody would always message me before the session and be like, "Hey, do it one more time, do it one more time." So it used to be goated like that. Uh, but now that we have a proper recording and been in this thing for like 2 years now, uh, and mostly because IGCSE was a long time ago, so I'm not a professional teacher either, so I'm gonna start to forget stuff. So I don't want to make a mistake in my teaching. So probably gonna let go of IGCSE, but I'm not gonna go away from this server. Uh, May June 2027, all of A level CS in 12 hours. Fuck yeah. It's time for the A level kids to experience that. I'm just glad we got P1 and P2 fully recorded finally without any problems. I'm really glad about that. It's gonna be in the archives forever. If the recording gets some issues. Oh no. It's okay, gang. It was really fun all 2 years. I remember when I first started with CS, it wasn't just CS. Uh, it wasn't just CS. I used to do chemistry as well. I did my first session was a chemistry session. Uh, uh, that was really fun. That was really fun. It was an ATP session. Uni sessions. Ooh, um, I'm very excited for university, Loki. I'm very excited for university. I have not decided yet which university I'm gonna go to, but I'm excited, even though I don't know where I'm gonna go. I'm gonna do so well, inshallah. No, you're not in college yet. I started teaching when I was in like in May June 2024 when I first did my first session. I was also giving May June 2024, so it was like I was also learning while I was teaching, side by side. Back then, I was 15 years old. I was 15 years old when I first joined the server and did my first class, and now I'm 17. I'm 17. I'm not 18. I'm 17. Yeah, 18 this year. Yes, you guys met me when I was 15, and I'm 17 now. Gonna be 18 in a few months. It's like how 2020 was 6 years ago. I was what 11 years old in 2020. I wrote my first website in 2018 or 2017, something like that, and I was what 8, 9 years old back then. It's so far behind that you don't even realize that it's been that long. Flexing. I finished my IGCSEs 2 years ago. But like there is one thing that I've realized is that um throughout these like 3 years, the last 2 years of A levels and the last year of IGCSE, when I first started teaching. The one thing that I've realized is that these syllabus contents, they can always be covered a night before. I swear to God, every single one of these can be covered a night before. You can cover each one of them if you're locked in enough. You can cover these all in a night. A level 2, man, I'm telling you, A level 2. I did physics P4, which is A level physics, in 2 days before the CAIE. If you're locked in, you can do these in 2 days, in one day even. Physics P4 was the longest I've ever grinded. You can do anything a night before. Literally anything a night before. Genuinely. It's not flexing, it's not 37 units, it's like 12 or something, 12, 13. CS Pre-2 a night before. That's the entire reason I do these sessions, because I know that somebody somewhere is gonna end up trying to find a recording that is covering everything in like 10 hours, and they're gonna just speedrun that. My paper is in 4 days now, and I can't even write pseudocode, bro. You just gotta practice a lot. Just practice every single past paper you can, as many past papers as you can, however many you can. Just past paper, though. Just practice those past paper in the less. Did you mention these in your college apps? Yeah, I did. I wrote like did a hosted community session, blah blah blah, on public forums and YouTube channels. I struggle with breaking down 15 markers. We're gonna do a past paper right now, and I'll explain it to you guys. I'll explain it to you. I'll give you guys the same explanation I gave AS, which is basically the same. So it'll be pretty easy. I'll help you guys. The only thing you need to know is that every single line that you write in your pseudocode, sorry, in every single line that you have in your question, each line is meant on a purpose. Okay, each line has a purpose. You have to interpret each line, and then you have to write your pseudocode accordingly. So let's. Anybody give me a past paper suggestion? Somebody gave me a past paper suggestion. We'll start from that. One of the hard past papers that you find. Variant and paper both. May June 25, which variant? February March 2026. You know what? Let's do February March 2026. Somebody send me February March 2026 in DMs. Someone send me FM 2026 P22 in DMs. Okay, then we'll do May June 20, May June 2024. Sure, that's my paper. Do hard question list. This is Feb March. All right, bet. Okay. Let's do February March 2026 P22. It all just sounds like ooh, ooh, ooh. Too young, too dumb to realize that I should have brought you flowers and held your hands. Should give you all my hours when I had the chance. Take you to every party, 'cause I remember how much you loved to dance. Do all the things I should have done when I was your man. Do all the things I should have done when I was your man. Learning on paper is so dumb. That's why I say get like extra sheets. May June 21 V22. Okay, we'll do like 3-4 papers. We'll do FM 26, we'll do May June 21 V22, and whatever paper anybody else wants. Let's start off with this one. Yes, yes, you can ask them for more sheets. I sent a reference above. Wait, where did it go? This is the Cambridge official documentation, and part of this external dispatch guide, there is a statement. This goes like this: hand out to candidates who need them. The components that require candidates to blah blah. Yeah. So yeah. If your center does not give you extra sheets, call British Council in the morning. Sorry, on Monday, call British Council on Monday and tell them that your center did not give you extra sheets, and let them deal with that center accordingly. Oh wait, yeah. May June 21 is old syllabus. Yeah, it is a major change. They added the 15 marker at the end. Uh, you can't ask for 10 extra sheets. You can ask for 4 though. They give you like 4 regularly. Let me show you guys how that works actually. Let me show you guys how that works so that you don't mess that up. Let me fetch in my the paper I'm about to show you is my AS level paper, but it's okay. It's the same thing. Let me just get this paper. And oh boy, that name sounds so familiar. Where is the transcript dog? Okay, let me get it from my. No, I don't know. I think my old friend was named Pranav. Mm, yeah. Yeah, I don't. You end up realizing that CAI is basically luck based as well. That is also another thing that you end up realizing. Ugh, stupid ass board deciding stupid ass futures. CS was created by people who love seeing kids suffer. Got it. This is 1 2. This is 229618. Okay, there we go. Let me save this to downloads and let me open this up. Okay. All right. Okay. I hope you guys can see my screen. Ooh, IBCSHL. That's a bit more complicated. I did an IBCSHL assignment for somebody I know. It's A level CS. It's A level-ish CS. IGCSE CS is easier. IBCSHL is a bit more in depth. Like for instance, one of the IAs is that you have to create a whole ass code in Python. IBCSHL is fun. I did not do IBs. I did IB for somebody else. I did not do IBs. Alright, so guys, if you do CS and IGCSE, don't do ICT as an F filler. Can you give my CAI for me? It doesn't work like that. Guys, by the way, this entire past paper, the funny thing is, the only preparation I did for this was IGCSE prep. Also, yeah, so look, this is how the extra sheet looks like, additional answer book. This is what it looks like, and right, so you do your rough work on here, and then you just make sure that you cross it afterwards, just like how I did here. Okay, I did the rough work, I made the procedures, the functions over here, and then what I did is I put a giant X on them, like this. Okay. You should use blank page, but I just didn't want to use blank page. I just wanted to not take the risk. You can use blank page as well. Yeah. But I just didn't want to use it because I just didn't. I just ended up using the answer booklet. You should use the blank pages before you use the answer booklet. What are APs? I believe you're referring to the American placement tests. Uh I guess you can think of them as IGCSE for Americans. They're a bunch, yeah, they're just the American education system. There you can give advanced placements. You can give freaky ass, easy. You can get easy fives on that, bro. You compare you compare AP calculus with our math, and you see what's happening in that country, bro. Anyways, okay, let's do. I use blank page. Bruh. Honestly, just ask for an extra answer booklet. Yeah. Yeah, they don't care. So what's recommended, IB or AP? What the heck? That you can't ask me. Avina, that's a huge skill issue. I'm on 1.6 million. I have no clue about IB or AP because I haven't done those personally. So okay, where is May, June 2026? Okay, sorry, February, March 2026. Okay, let me open this up and okay. Let me share my screen. All right. Is the paper visible to you guys? Okay, perfect. All right, let's okay, all right. So let's start this paper. Candidate name, ateebsohail. Center number P2058. Oh shit, that's my actual. Okay. P6969. 6969. Okay. Tick one box to identify the reason for applying verification. Check to input data. To make sure that all the data is in the correct range? No, that is validation, guys. Where is my? That is for validation, okay? To make sure that all the data is accurate, I guess. To make sure that no errors have been, yes. The answer is no errors have been introduced during input. Okay, that's the definition of verification as well. Uh, okay. Then identify the type of validation check used in each description. Each check must be different. A check to make sure that data input follows a set pattern, such as 2 characters followed by 3 numbers. Format check, pretty easy. A check to make sure that only whole number can be input. Type check. Pretty simple. We actually did the pseudocode for this one. Explain the reasons why validation checks are necessary when data is input. Okay, pretty simple. To ensure that the data input is reasonable and can be accepted into the program without any errors. Without any errors. Okay, that is 1 mark. Uh, how many marks is this? 3 marks. Ooh. What else can we add here, guys? Can we add an example? I think this would be 1 to 2 marks. What else can we add? Hmm? Nobody? 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 Okay. Does nobody want to answer? Damn. Okay. You gotta make sure that it's yeah. Okay. Uh, it can automatically reject data that does not meet the set criteria and can ask the user to re-input it. To re-input it. Uh, then you can say to improve the overall reliability. To improve the overall reliability, though the first 2 statements should be enough for 3 marks. You can also say that to prevent the program from crashing. To prevent the program from crashing. Pretty simple. Yeah, to ensure the input is appropriate for the task. That would have gotten you 1 mark, but you need 3 marks. The first 2 and the last statement should be enough. I don't think the third statement matters that much. This should be enough. Then you have okay. Write the pseudocode for an algorithm to perform a validation check on each number as it is input to meet the following criteria. Input 20 numbers one at a time. If a number is negative, store it in an element of array neg numbers. If the number is not negative, ask for it to be input again until a negative number is input when all 20 numbers have been input. This is pretty easy. I would suggest that you guys do this yourself on paper first before, and I'll do it as well, obviously. But I would suggest that you guys try to do it yourself as well. This is really easy. What we're gonna do is we're gonna start off by running a for loop for x1 to 20, and we're gonna input a number, and we're gonna see if num is negative. So if it's less than 0, then we're gonna store it. So neg numbers at, sorry, we're gonna introduce a repeat until. We're gonna do a repeat until because we are validating each number. Repeat input num until num, ask for it to be input again. So I guess we can output. So if num is greater than 0, then we can just ask for it to be input again, output, enter number again, right? Just like we did in the notes. So then we do end if until, until num is less than 0, until num is less than 0, yeah. And greater than or equal to 0, by the way. It's going to be greater than or equal to 0. Until it's less than 0, and then what we're going to do is we're going to store the number in neg numbers at x is equal to num. We're going to next x, and obviously we're going to then output completed. So it was pretty simple. I think all of you should have gotten this. Pretty simple. Teach me 3D bubble sort. Okay. Anyways, yeah. So that is gonna be part C. Any questions about this code? Guys, by the way, he's kidding. He's kidding. He's like a friend of mine. He's in A levels. Don't worry about what he says. Okay. Yeah, sure, you carry me, buddy. Okay, let's move on. Okay. Describe what happens in the analysis and design stages. Oh boy. Okay. So we know that the analysis stage was what? Used to understand the requirements of the current problem. Okay. Then you can say that, guys, what was the method? What was the one thing that it uses? There's one thing that it specifically uses. What was the name of that? Abstraction. Involves abstraction. And what exactly was abstraction? What was abstraction? Removes unnecessary details. And what was decomposition? Breaking down, yes. Decomposition. Breaking down a problem into a complex problem into smaller solvable problems. We can also write that it identifies the inputs, processes, and outputs. Identifies inputs, processes, and outputs. This should be enough for 3 marks. Then you have design, which is creating a visualization of the program or a structure of the program. You can say involves algorithms, like involves flowcharts, structure diagrams, and pseudocode. What else? You can say that it designs data structures, identifies data types, and helps make user interfaces. I think this should be enough for 3 marks. Okay. Then you have tick 1, which what does not help. So I told you guys this is a really common question. Though it's for 1 mark over here, it might come for 3 marks. I have a feeling that it's gonna come tomorrow. I don't know why, but I got a feeling that this is gonna come tomorrow. This one and the file handling thing that I told you about. I don't know why. But tick watch 1, which does not help to create. So meaningful identifiers does help. Remove blank lines to make the program code shorter. We'll get to this. Use procedures and functions, that helps. Use commenting, that helps. So that answer is B. B does not help at all. Okay. In these questions, always use the process of elimination. Okay. Okay, turnover. Nice. Okay. Identify the line numbers of 5 errors and suggest corrections. Okay, first, whenever these kinds of questions come, these kinds of questions, simple thing, the first thing you need to do is read this passage and see what the algorithm is actually trying to do. So it's sorting 200 names in ascending order using bubble sort. So you need to identify what the problem is in bubble sort. So now some common errors that you should already come to mind is that if it's sorting, then it's probably going to be the wrong sign in bubble sort. There's probably gonna be something regarding limits. Uh, there's probably gonna be something regarding swapping, like this. Okay, so let's go over this. Okay, the array names has already been declared as this, so we know that it's 1 to 200, and then it's a 2D bubble sort. Nice. So each one of those values have 2, so it kind of looks like this. So there's that, and then there's something over here, and this goes on for 200 arrays. Okay, so it's kind of like this. Whenever you're working with 2D arrays, it's always nice to visualize the arrays, okay, or visualize an example of the array. Okay. Okay. All right, so let's look over it. Swap boolean, first thing, they're given us declaration, so there might be an error in the string, in the declaration, but I do not see an error. But I do. Look over here. Row is an integer, but here they've defined it as a string. So the first error is on line 3. Okay, and the correction for this would be to use declare row as integer, because it's an integer, right? It's being used as an integer. So that's our first error. Okay, on line 3. Swap equal to false while not swap do swap equal to false. Okay, so I told you guys that we assume that the row that this array is sorted, and in order to assume that, we have to make this swap true. Okay, or whatever this swap is, it should be the opposite of whatever swap we're using outside, right? So this should be equal to true. Okay, so 0 9, and this is going to be swap is equal to true. Then you have the third error. Okay, from row 2 to 199. This is also an error. Why? Because we must be starting from the first index and going to the last minus first index. Okay, it should be row 1 to 199, not 1 to 200, because remember I told you that it should be the last minus 1. It should be the last minus 1, and the last is 200, so 200 minus 1 is 199. So it should be 1 to 199. Okay, so we're gonna, what's that, line number 10, and the correction is gonna be for row is 1 to 199, because it's last minus 1. Okay, then you have this. Okay, I think that there is an error over here. I think this is in descending, so I think this should be ascending or something. What do you guys think? Is this an ascending or is it in descending? Isn't it 0 to 199? No, this is 1 to 200. Is it good if you get 55 to 63-ish in paper 1 and 45 in paper 2? You can definitely get more than 45 in paper 2, man. Trust me. You can definitely get, if you practice how many ever days you have remaining, if you just practice like at least 4 or 5 past papers a day, you can definitely get there. You can definitely get like 65. in paper 2. But that's probably going to round you up at a B or an A, which is not nice. I think you should. It doesn't matter. It doesn't matter. Just keep on practicing. You're going to eventually realize there's patterns. Anyways, okay, so temp 1 and temp 2, we did that. So we're going to swap them out now. Let's look at the swapping. Okay, so there's an error over here. So this is gonna be next row because we're using row over here. So it's gonna be next row. So that is line number 21. So it's gonna be next row. Let's take a look at the swapping. Names row 1 is gonna be row 1. Okay. Okay, right over here. So you see right over here, right over here, look at this. This is the first column. It's being assigned with temp 1, that is the first column. This is the second column, it's being assigned with temp 2, which is the second column. This is the first column, it's being assigned with the first column, but this is also the first column, it's being assigned with the second column. This should be the second column as well. So this is line number 16, and it's gonna be 2. Okay, it's gonna be 2. Okay. Let me just a second. I remember somebody asked me this question earlier. So I'm just gonna send them the marking scheme that I just made. Okay. Anyways, moving on. Write the pseudocode for an algorithm using nested iteration to output the content of names. Pretty simple. Names is a 2D array. So what we're going to do is we're going to make a row and column, right? So for row 1 to 200, and then for column, how many columns were there? 2. So 1 to 2. What we're going to do is we're going to output names at row and column. Next row. Okay. Similarly, if you were to assign, you would have done names row column is equal to whatever value you want to make it. Describe a possible problem with the algorithm that could mean that the names are not sorted correctly. Okay, you could say that the algorithm only checks last names. Okay, so it could be like the names are swapped, right? So you could say that column 1 and column 2 are last and first names that are swapped together, right? Because it's an array of names, right? So it could be the last name is column 1, last name is first name is column 2, and because it does not evaluate column 2, because if you look up here again, you're gonna see that, oh, it's only checking column 1, not column 2. So you can say that it's not evaluating column 2, right? So that's gonna be the problem. What will be given? As far as I know, the 2D array bubble sorting has been given to you guys. I've never seen it being asked, but I am unsure. It's not that complicated. You just add a column to it. Like it's literally just normal bubble sort, except this time we're just adding a column to it. Bas. Khalas. What was the normal bubble sort? It was just without this, right? What we're doing is we're just adding a column to it, and then we're just making two swaps at the same time. We're just making 2 swaps at the same time. It's the exact same thing. Okay, pseudocode. So, like I told you guys, you want to put your finger on the beginning, on the start, bring it down. Input sentence. Okay. What is sentence? Computing is fun. They've already inputted for us. Sent length is length sentence. They've also done that for us. Great. Letter number is 1, start is 1. So we're just gonna send that 1, 1. Now, is substring at sentence at 1 1 equal to that? Is substring at 1 1 equal to that? That is C. Is C equal to an empty space? No, it isn't. So letter no is equal to letter no plus 1. Is letter no equal to sentence strength? It isn't. So we're gonna go back to the top. I do have A levels this week. I have CSP3 on Tuesday, further physics P5 on Wednesday, and CSP4 and further mechanics on Thursday. Didn't you say to start from second row? Yes, yes, but look, the initialization part, which is the part before the actual looping begins, we always write that in the first row. So like for instance over here, they already wrote these two for us in the first row. So that's why I looked at the next two and I realized that, oh, these are all part of the same group, right? These are all part of the same group. This is the same group, isn't it? This is all part of the same group. So that's why I wrote it in the same row. Okay. Anyways, okay. So next is letter no to, is O equal to that? No. So it's going to increment by 1 and it's going to increment by 1 again until the space is reached. Okay, which is going to be at the 9th character. Okay, 6, 7, 8, 9. At 9, what's going to happen is that you have this 3, right? 1, 2, 3, 4, 5, 6, 9. And then it's going to become 10. Now it's going to see, is 10 equal to an empty space? 10th is equal to an empty space. So what it's going to do is going to make the word equal to the freaking substring. So the word is going to become computing. Then it's going to output word space the length of the word. Yeah, it's going to output the word space the length of the word. So computing 9. Simple, right? Simple, pretty simple. What's going to happen then is that it's going to make start letter number plus 1. So start is going to become 11. And then it's going to repeat. Uh, what do you say? How to understand if you skip a row or not? The initialization, which before the row, which before our loop starts, usually we always write the initialization at the first row, which is why I did it at the first row. I'm pretty sure that CAIE marks you column by column, so even if you end up messing a line, I don't think that's going to be that big of a deal. I'm pretty sure they mark you column by column. But you basically write initializations on the first row. If you've already started your loop, then you start from the second row. Most of the time, you have to start from the second row. But I'm pretty sure they don't care. Pretty sure. This is 5 marks. Anyways, so then it's gonna go over and it's gonna repeat the entire thing. And you're gonna get like, what, 12? Right? You're gonna get 12? No, you're gonna get 11, 12. And at the 13th, it's gonna become 14 and it's gonna become is 2. And then you're gonna get 14, 15, 16, and then 17. Right, no, it's not gonna do anything. You're gonna become 16, and when it sees that it's the same as the sense length, it's just gonna get the substring word, which is gonna be equal to fun, and then it's gonna output that plus the length of the word, fun3. Okay. Okay. Explain the purpose of the algorithm shown by the flowchart. Okay, so it's obviously dividing words, right? So that's what you're gonna say. It separates words by the space character and outputs each word along with the length of the word. I think this should be enough. You can say from a given string. From a given string. Should be enough. 9618 lessons when? May, June 2027. 9618 is CSA level. As currently written, the algorithm may be difficult to understand if it was used as a program. See, I told you guys, maintenance. Okay, so identify 3 improvements that can make it more user friendly. So look over here. You could add an input before sentence. You can make a prompt for the user. Like you could do something like prompt the user to enter a sentence before inputting, right? You could do that. That could be 1 mark. Make the outputs better worded. Make the outputs better worded. E.g., something like word is the word and length of word is the length, kind of like this. You don't have to write it exactly like I did, but it's just an example. Then you have another point could be adding validations for multiple, adding validations like presence check or length check, right? That could be useful, or type check. And yeah, let's move on. Time to make the Boolean logic. So whenever you're working with Boolean expressions that you have to make into a circuit, adding comments won't help the user. They said user friendly. They said user friendly, not friendly for other programmers. They did not mention maintenance. They said user friendly. Now, whenever you're working with drawing out logic expressions, it's always better to draw out the one in the brackets and then we deal with it. Okay, so you first draw out this one. Okay, so we're gonna say A NAND not B. So A NAND not B would just be, first we're gonna plug the B into a NOT gate like this. And this is gonna go out and go into a NAND with red. NAND. Okay, pretty simple. And then we're gonna do the other bracket, which is A NOR C. So we're gonna make the NOR gate. Like I said, it's always better to make the brackets first, and then we're gonna make the middle gate, which is an XOR gate, which looks like this. I just realized that we didn't do XOR gates, how the XOR gate looks like in the notes, but this is how an XOR gate looks. Okay, and then this NAND goes into here. Oops, but anyways, yeah. Complete the truth table. Now, the way that people do this is by assigning letters. So you could assign, for instance, you could make this one D, you could make this one E, and then obviously the final expression, and you could make this one like F. So first let's calculate F, right, which is just not B. So we're gonna say, let me just delete this, okay. So F is just not B, so F is not B, so what? Let me just delete all of this. So it's 1 1 0 0 1 1 0 0. Okay, pretty simple. Then D is gonna be F NAND A. So D is gonna be F NAND A. So we're gonna multiply, okay, and then we're gonna flip. Why does A diverge into 2 different paths? What do you mean? Like this? Yeah, that's allowed. This is allowed. This is what we call a junction. Yeah, it's allowed. You can do this. Okay, so D is what? A NAND F. So A NAND F. So 0 is 1 and is what? 0, so it's gonna become 1. 0 1 is what? And it's 0, so it's gonna become 1, and then so on. And then 1 and 1 is what? 1, so it's gonna become 0. And then 1 and 1, 1 and 1 is what? 1, so it's gonna become 0. And then 1 and 0 is 0, so it's gonna become 1, and then 1 and 0 again is 1. Pretty simple. And then you have E, which is just A nor C. So we're gonna make E, which is A nor C. So 0 plus 0 is 0. 0 plus 0 is 0. So that's gonna be 1. 0 plus 1 is, and then I'm gonna just do the rest really quick. 0. Oh wait, oops. 1, 0, 0, 0, 0, 0. The basic for the basic for OR was that if there is a 1, then the whole output is going to be 1. And then X was just E XOR D. So if same, then false. So hence this would be 0. This would be if same, then false. So this would be different. So it's going to be true, then 0, then true, 0, 0, true, true. So our final answer would be 0, 1, 0, 1, 0, 0, 1, 1. Pretty simple. This is the easiest 4 plus 4 marks you'll ever get. Now, databases. State the number of fields and records in this database table. So there is 1 field, 2 field, 3 field, 4 fields, 5 fields. So there are 5 fields. Okay, pretty simple. And how many records are there? 1, 2, 3, 4, 5, 6, 7, 8. I should not be writing over the IDs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 records. Pretty simple. Okay. The data in both ID code and country fields are unique in the database table. State one reason why ID code would make better primary key than country. What is a primary key? It's a unique identifier. So you can say that ID code is not repeated. It's completely unique. So you can say ID code is completely unique and cannot be repeated. And you can make it more relatable to the question because it's national trees. So tree can appear in one country can have more than one national tree. One country can have more than one national tree. So you can say that. So you can make it more relatable to the question as well. Okay. Then you have give the output that will be produced by the following SQL statement. Okay. Select ID code, country, common name where from national trees where continent is Europe. Let's select those ones first. So we know that the continent is Europe is this right over here. Where's my pen? So this one, then this one, then this one. Now SQL outputs are always on a different line for each record. So let's look at what it wants. So it's gonna output ID code, country, and common name. So what is the ID code? EU121, comma, country, what is the country? Albania, and then common name is olive. And then the next one, okay, the next one is what? EU321, Cyprus, and golden oak. And then the next one is what? In Europe, EU652, Finland, and it is silver birch. All right. Then you have complete the SQL statement to list only the country, common name, and scientific name of the national trees for North America in alphabetical order of their common names. Pretty simple. So what we're going to do is we're going to select the country, common name, and scientific name. So country, common name, and scientific names. Select country, common name, scientific name. This is 1 mark from the table, which is national trees. This is 2 mark, where continent is equal to North America. This is 3 marks, and then order by what is the common name. So common name 4 marks, ascending 5 marks. Okay. Pretty simple. When do we add commas? We only add commas between the field names in the select. You don't add commas otherwise. There are no commas in SQL besides the field names. Semicolon, they already added it for us. Look, they already added it for us at the end, so we don't add it. They already added it for us. Yeah, that's what I meant. They mostly give it to you, but if they don't, then only you add semicolon. Is this a 15 marker? All right, bet. Okay. Okay. Yes, that was very short. It should be the easiest marks that you get. Okay, so a program is required to enable voting in class surveys. For example, to find the most popular smartphone. The one-dimensional array options is used to store between 2 to 12 options on which users can vote. The one-dimensional array votes is used to store the votes of between 2 to 1000 users. The one-dimensional array vote count is used to store the number of votes for each of the options. The array index. Everybody, please read this question. I'm going to give you 2 minutes to read this question. Take 2 minutes to read this question. Okay, so go to part on AM4. How do you know I'm playing AM4 right now? I think my planes are. Yeah, most of them have landed. I have a really weak fleet right now. I just started playing a while ago. I have a really shitty fleet right now. Very, really bad. Anyways, what was I saying? Right. So a program is you required to enable voting in class service. So they've told us about 3 arrays. The option array basically has all of the 12 options. You were stalking my account. How do you know about my? Oh wait, you're probably in the server and you. Okay, yeah, got it. Anyways, right. So the options is basically stored, used to store the names of the models. I'm guessing, right? The options. The votes array is used to store the votes. So each vote is gonna be an option, okay, an option code, and the vote count is used to store the number of votes for each of the options. Pretty simple. So they told us that we need to start by initializing the okay, we need to start by initializing the variables. Okay, so whenever you're working with a 15 marker, you have to remember one thing: declare, statements, and then test. DST. Declare, state, trust, test. First off, you want to declare. You want to, if they said that, if they explicitly said, like they said here, they said do not declare arrays, then you can skip the step. But if they said declare, you must declare, then, or they didn't mention this at all, then leave around 5 spaces for declaration, 5 lines for declaration. 4 to 5 lines. Okay. Then you want to move on to the statements, which are these. The first thing is that initialize all the arrays. So in order to initialize all of the arrays, what are we gonna do? I'm also gonna bring this down to Obsidian actually. I think I'll bring this down to Obsidian because this is gonna piss me off. Let's bring this down to Obsidian. Okay. Let me share my screen. Okay, there we go. Okay. So they told us to initialize all the arrays. So we're going to initialize all the arrays for, let's just initialize the first one, 1 to 12. What we're going to say is we're going to say options at X is, we're going to input actually, we're going to input each option, okay? Because they're the voting options, right? They're the names of the voting options to find the most popular smartphone. So we're going to initialize it by taking an input from the user. Input option, we can output, enter option, output, enter option, and then we're gonna input option and we're gonna store it. Okay. There is a possibility where you might have to use a while loop, but I don't think it's gonna be that complicated. Because the reason I'm saying that you might have to use a while loop is because they said it's used to store between 2 and 12 options. I don't know if they mean that. Do they mean that we can store like 4 options at a time, or do they mean like there have to be 12? I think they mean that we can store 4 options at a time, right? What do you guys think? Like we can store any amount that is between 2 and 12. I think we can store any amount that is between 2 and 12, right? I don't think it's 1 to 11. That's what I'm confused about. I think it's because like 15 marks, and look, they said initialize all the arrays, input and validate the number of options and voters. So you can see they're literally telling us to input and validate the number of options and the number of voters. So I'm pretty sure that we have to input each of the required options, and then yeah, I'm pretty sure that we have to take the input that we have to take the input of how many options, and then we're gonna, yeah, I think that's it. Okay. So what we're gonna do is we're gonna start off by initializing the array that we, yeah. So we're gonna start off by inputting the, actually let's populate. I think we should go, remember you should go in sequence always. So we're gonna start off by just initializing all of the thingies. So all of the arrays. So for x is 1, for x is 1 to 12. We're gonna initialize options at x to an empty space, and we're gonna initialize vote count at x to an 0. Next x, and we're also gonna initialize the votes array. So for x is 1 to 1000, votes at x is gonna be -1. Okay, next x. Okay. Wouldn't it be safer to say no? No, because they said it can have 2 to 12 options. They don't literally mean that there's option number 2 to 12. They mean that there has to be a minimum of 2 options and a maximum of 12 options. That's what they mean. Shouldn't vote count also be? We are initializing vote count right over here, because they're the same length now, so I put them in the same for loop. Okay, so that's number 1 done. Now we want to input and validate the number of options and the number of voters. So what we're going to do is we're going to input these. So we're going to say repeat. All right, we're going to say repeat input number options. Okay, we're going to make an output first actually. Output enter number of options, and we're going to input num options until num options is greater than or equal to 2 and num options is less than or equal to 12, because this is set to input and validate it. Okay, and then we're gonna do the same for number of voters. Enter number of voters. Let's just yeah, num voters, and we're gonna change this to num voters. They said it's between 2 and 1000, right? So num voters is greater than equal to 2 and num voters is less than or equal to 1000. Done? Okay. So then what we're going to do is we're done with input and validate the number of options as well. Okay. Now what we're going to do is we're going to input each of the required options and store them in the array options. So what we're going to do is we're going to make another for loop for x is 1 to num options, because num options, and we're going to output enter option, and we're going to store that option into the array. So options at x is equal to opt next x. Pretty simple, right? That is point number 3 done. I'm pretty sure for this much you can get like 6 or 7 marks right here for just this much. When do we initialize the blank space with the 0? You initialize it with the 0 when they specifically ask you, and when it's an integer and they're like, oh, make it 0. Okay. Then you have display the list of options for each voter and allow each voter to input their preferred option. Validate this input and store it in the array of votes. Okay. Pretty simple. What we're going to do is we're going to do for x is 1 to num options. 1 to num voters. What we're going to do is next x. Okay. What we're going to do is we're going to show the voters each one of their options. So to do that, we're going to do another for loop for x is for y is equal to 1 to num options. And what we're going to do, output options at y ampersand id is what? Y. Okay. Yeah, those are their options. Actually, I think. Well, yeah, I don't think. Never mind. Yeah, we're just gonna do this, and then we're gonna show them their options, and then what we're gonna do is we're going to we'll do comments at the end. I always do comments at the end. We're gonna do we're gonna input the option, output choose an option, and then we're gonna input the option. Okay, and what we're gonna do is they said that we need to validate this input as well. So we need to make sure that the option they chose is between 1 and 12. Okay, so we're gonna repeat and we're gonna input our options and the output. Okay, until option is greater than or equal to 1 and option is less than or equal to 12. Any confusion so far? Yes, indentation is necessary. Any confusion so far? Any confusion so far whatsoever? How much indent should we keep? Not a lot. Like 1 finger's worth per indent. 1 finger's worth per indent. Something like that, yeah. 1.5 to 1 finger's worth. Well, I think we're running out of time, so this will be the only paper we do, and then I'll explain to you guys how to attempt the entire paper. Why is votes array being initialized as -1? I just made it -1 because it's random. Because listen, how many possible votes can there be? What are the vote option IDs? It's 1 through 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how we're storing it, right? How we're gonna store it. Yeah. I guess you could kind of take it like a string as well. We could have also done 0. Yeah, we could have done 0 as well. We could have done 0, absolutely. We could have done 0. We could have done 0, absolutely. Shouldn't it be greater than or equal to 1? Shouldn't it be greater than 1? No, because our options are 1 through 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've given each option an ID, right? We've given each option an ID. So the first one obviously starts at 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have one the voter to choose from 1 through 12 inclusive. The reason we did 2 to 12 here is because they said that the number of options must be between 2 and 12. But that doesn't mean that there are going to be 2 and 12 options. it means that there's going to be a minimum of 2 options and a maximum of 12 options. That's still a maximum of, it should be, oh, let's say this should be this shouldn't be 12, this should be num options, but that basically means that however many, we're going to start at 1 because it's going to be starting at 1, and then 1 2 however many options there are. Okay, it should be less than equal to num options. But yeah, the 2 to 12 is that there can be a minimum of 2 and a maximum of 12 options. That's what the 2 to 12 is. But it's always going to start at 1. It doesn't mean that the starting index is 2. It means that there's going to be, we're not done with the question. I'm just asking if we have any confusion so far. This isn't a difficult 15 marker. This is a pretty easy 15 marker. We're done with this point as well. Display the list of options and allow each voter to input his option. Now, they said once all the votes have been input, count the number of voters who chose each option and find the least and most popular options. Pretty easy. What we're going to do is we're going to take the option and we're just going to increment whatever the value, whatever the index at vote count is. Okay, so we're going to say vote count at the option is going to increment by 1. So vote count option plus 1. Okay, that is the first part of the of this. And now we need to find the least and most popular options. So pretty simple. What we're gonna do is we're gonna go through this array. So there's 2 ways you can do this. You can sort the array and just take the last and you can take the last and first element, which is pretty easy, or you can find for it. So like you can just make a max minimum algorithm. It's up to you, whichever one you want to do. I think I'll go with the max and minimum route. So what I'm gonna do is I'm gonna say max is equal to, what is the least possible amount of votes? 0, right? And what is the min? What is the maximum amount of possible votes? It's 2000, right? Because there is a possibility that all 2000, 1000, sorry, it's 1000. Or you can make it any large number, honestly, any number that is greater than 1000. Okay, you can make it any number that is greater than 1000. Then what we're gonna do, you could also do vote count at 1, by the way. You can also do it this way. This way is also completely valid, 100%. I think I'm gonna go with this way because I taught this way in the notes as well. So yeah, for x is equal to 1 to length of for 1 to num options. If num options at x is greater than maximum, then max is equal to num options x. Okay, and we're also gonna store the id. Okay, max index is equal to -1, sorry, is equal to 1, and min index is equal to 1 as well. So when we find out that, oh, this is maximum, so we're gonna make max index equal to the current x value, and if num options at x is less than minimum, then minimum is num options at x and min index is going to be x, and if, and then you can do next x. That way we have found the maximum and minimum option. Okay, that is how we found them. Easy peasy lemon squeezy. Output the most and least popular options as well as the number of voters who selected each of these options. Pretty easy. We're gonna say that we're gonna output options at max index. Sorry, we're gonna say output most votes for output options at max index, output vote count, output vote count max index, and we're gonna do the exact same for the minimum index. Least, honestly, you could have used ampersand here as well, but the reason I'm not using it is because Puppy did say that it's not part of the syllabus. So yeah. output the most and least popular options, and yeah, that's that. And yeah, we're done. This is our pseudocode. Obviously, you're gonna add comments to get that entire 15 out of 15 marks, but this is our pseudocode. Any questions about this pseudocode? I'll also send it in chat. I'll also send this entire solved paper in chat as well. And since there are no questions, let's talk about the final tips and tricks and end the session. Did we store in array votes? What do you mean? We stored in the vote count the number of votes for each option, and we stored in the votes the number of the option each voter got. Right? Didn't we? Oh, there is one line. There is one line that I forgot to add over here. There's one line that I forgot to add over here. Right over here, we forgot to actually store the option. So we're gonna say vote at x is equal to option. I forgot this line. Because like we have to, sorry, votes at x, because we have to store each individual person's option choice as well. So pretty simple. Honestly, yes, but don't do that because you should always output meaningful statements. That one doesn't output meaningful statement at all. That does not look like a meaningful statement at all. And yeah, I think that's it. Let's talk about. Could you zoom out to show how the whole code? I sent the whole code in the chat as well, so you can just look at it over there. But here you go. All right, so let's talk about final tips and tricks. First of all, use pub notes to go over the theory so that you can get actual marking scheme related answers. All right. How much is AM4 fuel right now? What the hell? You got my mind stuck on the game. Oh, it's cheap. Oh my god. Okay, wait. Let me just depart all of my shit. Hold on, guys. Guys, hold on. I am sorry, but you will need to hold on a bit. Your man needs to do some departing. Okay, depart. Uh, well, it's cheap fuel. You can't really blame me, can you? All right, there we go. Anyways, as I was saying. All right. Okay. So, like I said, for P2, go over the theory. Make sure that you know the MS-based answers. Make sure that you know the keywords. Chapter 7 is a question. They ask a lot of theory-based questions from Chapter 7. Make sure that you know the PDLC. Make sure that you understand how file handling works. Make sure you understand databases. Make sure that you understand Boolean logic. Boolean logic in databases, you should not lose a single mark at all. And the theory questions. Absolutely not. You're gonna get at least 40 marks for the theory questions, 0 marks lost in that. Okay, make sure that you know the definitions, make sure that you know how to do SQL, make sure that you know all of that. Practice that, do topicals. You have 4 days, spend 2 days on topic on just perfecting theory. Or 1 day on perfecting theory. Spend a day or two on perfecting theory. Then practice pseudocode. A lot of pseudocode, so much pseudocode. Use the pseudocode pro IDE, HTTPS pseudocode pro. Try to do May, June 2025. Try to do October, November 2025, May, June 24, and October, November 24. 24, 24, and 2025. Try to do at least 4 papers, right? If you're variant 2, try to do May, June 2024, 2025, October, November 2024, 2025, variant 2. At least do 4 past papers. Man, 4 past papers in 4 days, so easy. I would suggest at least do 16, 4 per day. Okay? but there aren't actually 4 past papers. There are like 3 variants per session. Do those 3. Okay, that's what 12 past papers. You can do 12 past papers in 4 days. Then try to solve. If you run out of pseudocode practice, try to solve the pseudocode questions on Pseudocode Pro's website. And whenever you get into a hurdle, if you're confused on a pseudocode question, send me a DM. I'll try my best to reply to you. If you have any question about any topic, anything that was wrong, you can always refer to the recording again. I'll be sending these notes. What does ampersand do in pseudocode? Ampersand. Chat GPT is giving my code an 8 out of 10, 8 to 10 out of 15. What's it saying wrong? I didn't add comments. I said khud kar lena comments. Do comments yourself. Comments give you additional 1 mark. I get like 12. Use Claude. Yeah, true that. Let me plug in my answer in Gemini. Let me plug in my answer in Gemini. Also use comma ampersand. That's a big confusion. Just use commas for output. Just use commas. Ignore the ampersand. Just use a comma to concatenate. The max bin output is flawed. Hello? Excuse me? Okay. Sorry, I put it into Gemini and I did do a few codes. Like for instance, right over here, I did option +1 inside of this. This should have been outside. That's my bad. I was meant to write it outside. I'm probably not looking at my screen. But and over here, what I did is I made this num options. This should have been options. Sorry, this should have been just what do you call it? Fuck, what do you call it? Which array was this? Vote count. Yeah, vote count. Just some blind errors that I made, just some typos. Logic remains the same. Logic remains the same. It's just a bunch of typos here. My bad for the typos. I'm just half asleep right now. I just made like a +1 inside of the array and wait, let me put this into Gemini. Adding 1 mark for comments. Mark this code strictly out of 15. Give me just the marks. Just some small typos I made in my sleepy ass. What's the question? Paid Claude. I'll send you the question, man. I'll send a screenshot. Just make sure to tell it that just make sure to tell it that ignore the comments requirement. Okay, never mind. These aren't going away. Okay, Gemini gave me 14 out of 15. Okay, I'll take that. I don't know why it didn't give me a 15 out of 15, but I'll take that 14 out of 15. Okay, most of it is correct. I'll send you the question. Tell it to give me the marks. Assume that comments have been written. Ugh. Uh, Here. No, there is no MS. This is February, March. Anyways, as I was saying, if you have any queries, feel free to message me. Go over the freaking recording again if it helps you. If you're confused anywhere, try to do at least 12 past papers, the 2024 and 2025 past papers. If you run out of past papers, you can always do the specimen papers. And if you run out of specimen papers, then you can always do Pseudocode Pro's example questions. And if you run out of those, do AS papers. Seriously, do AS pseudocode papers. Don't look at the syntax, just do AS pseudocode papers. No, then you're ready. You can never be ready, man. You can never be ready. You can never be ready. But yeah, guys, that's it from my side. Good luck for your papers. we're gonna conclude it here. Last IGCSE session. Can you show an AS paper? Maybe some other time. Or you can just go over the AS recording. I did take an AS recording. You can go over it if you go over to the ASAL channel and check the pins. There is a pin of mine. Open that. There is a recording for my AS session. I showed off my ASP2 over there, so you can go over there and check that out. All right, guys. 2024. See you guys. Let me know how your paper goes. And again, if you have any questions, feel free to DM me at any time. I'll take my best to respond to you. See you guys. You can just DM me. Sure, man. But I don't know if I'll be having time, but just DM me with the solution and the marking scheme. I'll mark it for you. All right, guys. Have a nice rest of your day. Bye bye. Good luck with the paper. Let me know how it goes. Let me know what came and everything. Peace out.